Yes, we are.
I'm fucking pissed. I mean, there isn't a fucking scale on this goddamn planet that can measure how fucking pissed I am right the fuck now. Hey, so yeah. I can't get any of these cowardly fucks to debate me unless someone can give me a good fucking reason to keep doing this. I'm fucking giving it up. I got better things to do with my time. Nobody ever cites my work. My Angles to Polaris video. Nobody ever cites that. It's not the best one in the world, but you know, it's fucking something, you know, with a physical model. And it gets a lot of compliments. So I know it's not complete shit. Nobody ever plays my videos on their live streams. Or even little bits of it. When was the last time anybody shared any of my videos? You know, my most popular video is the Angles to Polaris video. And it has less than 1,000 fucking views and it's 2 years old. And I've got a shit community fucking not doing anything to fucking keep me doing it. Like I said, unless someone can give me a good fucking reason why I should keep streaming, you know, I'm done. So, thanks for the fish. I'm so pissed off right now. I've got a shit community. Made me look like a fucking asshole. Motherfucker! Fucking asshole! Motherfucker! I'm so pissed off right now.
Your world is full of illusions, contradiction between fact and fiction.
Fucking talking shit.
You never back your claims.
Like a little cowardly bitch. Fucking talking shit.
Driving the wrong way down a one-way street.
Motherfucker!
Unstoppable force on immovable feet.
You don't know how fucking pissed I am.
Straight lines converge in the distance.
Fucking asshole.
Why do I get so much resistance? I know.
Fucking talking
You'll
shit.
never prove me wrong.
Right the fuck now. God damn it, fucker.
Now we get our physics deniers. Pathologic compulsive lies. I know. You'll never prove me wrong.
You don't know how fucking pissed I am.
Driving the wrong way down a one-way street.
I get fucking emasculated by Jose J.G. Gonzalez.
It's where knowledge and ignorance meet.
Fucking asshole. Motherfucker.
Paradoxes and confusion. Your mind is in delusion.
Fucking talking shit.
We all know you're insane.
God damn it. I can't get one of these pussies after fucking talking shit to this motherfucker. I fucking still like him, but he fucking pissed me off. Motherfucker! God damn, he owes me a fucking apology.
Talk about your 2D surface. We all know you ain't got no purpose in life. When you think that you live on board.
I get fucking emasculated.
Driving the wrong way down a one-way street.
I get fucking emasculated by Jose J.G. Gonzalez.
It's where knowledge and ignorance meet.
Fucking talking shit. Motherfucker!
Paradoxes and confusion. Your mind is in delusion.
Fucking talking shit.
We all know you're insane. We all know you're insane.
I get fucking emasculated by Jose J.G. Gonzalez. And I'm pretty fucking pissed off. That's all I've got to say about it. Motherfucker! motherfucker! Made me look like a fucking asshole!
And we are live. Welcome. This is I think they're rapidly becoming my more favourite or fun day. It's like comedy evening. This Model Affliction Monday. Not wanting to laugh at Model Affliction. It's a very serious thing. But some of the consequences of it are hilarious. And that's what we want to go over. We don't want to mock the model afflicted. Just the affliction. The things that the model afflicted have to say. The position that they've been put in. That's what we're going to go over today. And it's been taking a while. But think we should really go over the Globe Surveyors. I know they all disappeared quite a long time ago, gone into hiding. I don't think they're ever going to come back. But some of the reasons that the Globe Surveyors have disappeared, left the arena. So we'll go over a few bits. Go on.
I'd like to talk about how bad that situation has become. When B-Ball and Blue are your authorities on surveying, you've gone pretty low. And Blue will say that he never has said he's a surveyor, which is true. But everyone looks up to him, even today, as one of the leading knowledge about surveying. You just go to Blue. And B-Ball is touting himself as he's been measuring things with surveying equipment, which is, about as good as they have. All the other claim to be surveyors have gone.
Yeah. Yeah, or, well, like you say, when I came in from Twitter, I talked to these people on Twitter. Straight talk to them. Tweeted 160 characters, all that old school stuff. So I initially came around these parts so I could talk and converse with I had questions that were never getting answered in tweets. So I came to ask some questions. I did. I got to talk to Jesse Kozlowski once, in which I've got the classic clip. I think you were there as well, Ricky, that day. I think it was over at Jose's. It was one of those good old days, comedy routines, double team. So, I ever since then, I've also talked to that other guy, the one that lives in Maine, or well, the one that may or may not live in Maine. We don't know. Talked to him over with McToon, in which McToon was pricing up jobs for him. So, I mean, obviously McToon had a higher ability for doing surveying than the guy who may or may not live in Maine. But we're going to go over a few of the things this week, I think. A few of the things we've found about these Globe Surveyors. And I differentiate these Globe Surveyors from surveyors, because these guys think that level is curved for some reason, because of the model affliction. Model affliction is the Model Affliction Monday. So when we first came into this, I mean, everybody was always saying, water level and all of that, but we used the water level, the tool, within our geometric principles. And I think that might have been new when we first started talking to people using our particular way of asking questions and trying to be specific about what it does. So we've ended up in a position now where because some of the reactions that people had back to us back in the day and the label we got because of saying that level is horizontal, which it observably is, and provably, geometrically, it is. And the link between level and horizontal is that they are practically identical, except horizontal is a geometric term and level is a practical term. Both the same thing. But because of the consequence of people deeming that being flat earth rather than just as it is in reality, they've had to take an opposing view of it, which has led to multiple different consequences. There's the drop or the hump. That's the big question. Even to the Globers, right? Because they must have different ones. You've got to have two different views of what you imagine. You have to have the drop and you also have to have the hump. You have to have both. It's contradictory from the get-go.
Dialetheism.
Mm-hmm. And if you can allow one contradiction, then you're obviously going to develop more contradictions because you've got a contradiction that you've allowed for. Develops more contradictions, and you're in a downward spiral of contradictions everywhere. You have to be completely oblivious to all of them. Some of the things that people say are a little bit strange. Hopefully we're going to go over. I've got a few videos to go over. And like we were saying just a bit earlier, blue seems to appear in these clips quite a lot. We're seeing as he's not a surveyor. Never had or claimed to have had any sort of surveying background at all. Which is strange because I think I'm the only one with a surveying qualification. Just a piece of paper.
He did claim today that he's taken the contractor's test, which is implying that he had his contractor's license at one point in time. And they did have questions on there about, surveying and how to use the tools and things, which he is correct about that. But I never knew he had a contractor's license either.
Oh.
Learned that today.
Nice. Well, so, I mean, the actual principles of a level should be pretty easy for them to understand. It's just that since then, they've injected a model into it. And for some reason, they've developed that into a geometric consequence of vertical and down. Which is another one of the contradictions that they have. Down has to be in every direction. Even relative to the down that you're talking about turns into an up. Not only is it every direction, it also turns into up. Once you go down enough. Think about it. That's a model. That's a paralogism that everybody holds. And you have to accept it. There's no way around it. Model Affliction says you're going to have to believe this sort of stuff. Just go with it. Don't worry. Oh, you've seen the I've got the bendy level on the YouTube. Got all the crew on it, all the potato squad. See if you can see all of them. I bet there's some potatoes that I haven't got on there. Let us know if you can see her. If you don't see one of the potatoes, and we'll make a potato for him. Peach, Jesse, Soundly, Sean. We still support you, Sean. Brad, Blue's even on there. Ruhif, Turkey Bob, FTFE, Ranty. I put Ranty on it. It goes on the bendy level. Baby Sly, the Rump Leech. They're all of the ones that run away. Nobody wants to talk to us anymore. Geometry's tough. So let's have a look at some videos. All right, yeah, I'll save that one. And you guys want in Discord. Right, these are a few videos, some old ones, some maybe, I don't know, most of you might have heard them, but it's fun going over these videos.
Yeah, you're always gonna find something you missed for sure.
Oh. There you go. Right. This is Globe Model Dictates. The first one of the earliest things. I think this was when Buster heard us, and this is back in the good old days when me and Spot On were talking to Zanuck. Right.
We gonna keep on fighting? Are we gonna keep on dividing? Well,
level. Demonstrate that the surface you're using is flat, and none of you have ever done that. Why, I wonder?
If I used a liquid level, you would say that the surface isn't flat because water curves around Earth, correct?
If you'd use a patch of water the size of a table, that'd be fine.
Okay, so
And a long level, a level the size of the table, that would be sufficient.
Okay. Wait, so you're saying if I took a 6-foot level and put it on a table, that level and table are perfectly straight lines?
I'm not really sure where you're going with this.
Okay.
I know. It would depend. It would depend on the actual experiment, wouldn't it? We would have to see it, but I would rather you show me an actual experiment.
I'm asking
that
you
propose some hypothetical one that you might do at some point in the future if we don't object too much. What's the point of this? Are you proposing some
Objection
on the table? Go ahead.
Right. If you had a mile-long level that was perfectly flat, straight, and laid it on water, one side making contact with the water, the other side would be 8 inches above the water. Okay?
The level surface drops down from the horizontal plane at a rate of 8 inches times the distance in miles squared.
Why? Because the geoid dictates that the gravitational force orientation is such that it actually gravitationally is going downhill, but physically going uphill.
The auto level. There you go. You're getting that. This is some of the old stuff. The model dictates. He said that.
Geoid dictates.
Yeah.
So their master is geoid.
Yep.
Hail the master.
His globe. So it's the basic framework that they end up with, or they start off with. And again, the local problem that they also have, because they can't define where local is. The problem is, it leads you into a place where you have no options other than what the model dictates, but you don't really know what the model dictates because it's all contradictory.
We had one give a distance today. I think it was foolish. SE might be able to back me up on this. 50 miles or less. 49 point whatever miles he said was to his job or less was local.
No,
Yeah, I think he said, if I'm not mistaken, it was foolish for sure. If I'm not mistaken, he either said 30 kilometers or 30 miles.
Yeah, I think it was 50 miles, 30. But he definitely gave a distance.
Yes, yes.
Seems like it was less than 50 miles. It was local to him.
Yep,
Yeah.
somewhere around there. Yep.
He kind of premised it with he has people that, you know, sometimes when it's within their state, it's local, or they're willing to drive 250 miles to a party, they consider that local. But basically what he was saying was 50 miles or less for him.
I've had people tell me 200 meters, a mile. I've had all kinds of different ballers give us different distances for local.
You know how far I've had once I press them geometrically? A point.
A point.
Yeah.
Oh yeah, shout out Rumpers. Yeah.
That's it. That's how local I get.
Yeah.
Because they know the geometry, the geometrical principles of this is if you have 2 points, that's all you need. You can extend them indefinitely in a straight line. You establish a straight line, and that straight line screws the ball over. There are no straight lines on the ball.
Oops.
Yeah, that's it. The straight line leads everybody into these paradoxes, and just because they're trying to skirt around the fact that there's a model there.
Oh yeah. Sorry, Bev. Before you go on, speaking of paradoxes, before I forget, we have a new paradox on the scene. Rakia, would you like to say it?
Yeah, we named it the local, non-local pipe paradox.
That's Rakia's baby. So check this out. They tell us that they have a pipe 5 miles long, let's say, a straight, level, but somehow the water pools in the middle. Rakia made them say that one. So shout out to Rakia.
Yeah, and Tony's right in the chat there. He says, we're trolling ourselves all because they have fuck all. They've got nothing. So we're having a laugh and a joke about the new stuff that comes out of the mouths of the model. Because it's a hive mind, isn't it? As soon as one of them says it, then everybody else has to say it. Otherwise,
it's the Borg.
Yeah. Well, if the
Borg.
model's dictated it, and that's the model answer, then you have to get on board with it, no matter how stupid it sounds.
Once the Queen says it, the Borg have to follow suit. There's no way around it. Resistance is futile.
The Borg says it. You have to too.
That's it.
And then this is what we've been doing. Like, gradually over the few years that we've been talking about this, we've been showing you and everybody what the model has to say. It won't change. You can't get it to change. The model dictates it. There's not much you can do about it.
Yeah. Oh, and another crazy one they said yesterday. Sorry. If you fill up LIGO tube, one of the LIGO tubes with water, the water would pool in the center, and either end there would be a gap.
That's been going for quite a while, that.
Oh, you heard of one that with the filled with water, LIGO?
Yeah. I think Rakia was doing that a bit ago. We had that straight line, isn't it? It's the spirit level.
And
the
we had
bubbles, which
that one,
is
but today they came up with the pooling of the pipe is definitely Rakia's. There's no question about it.
Yeah, because
today
they're
came up
letting
with
you know
pooling in the center, water pooling in the center.
Yeah, because it's straight, isn't it? See, their concept of horizontal goes up, and then they have level in the middle of it, which is then becomes straight. Except in their mind, they're curving. And then that recurve of the horizontal makes the level curve. It's the straightening of the horizontal.
Yeah, I did this a couple of years back. I'm like, what are you talking about if you fill that tube up? Yeah, horizontal.
It's just so backwards. The whole thinking is like they have to make one flip so then the other. But they separate level from horizontal because they both can't be the same. But then they have a paradox that they've got the same thing but different.
It's insane.
Yeah.
It's really unbelievable. Just to hear them say the stuff that they say, man. Wow.
I'll go back to a bit. There's because I've got about 4 videos, and it's just the beginning bits of all of them, really, where all the little clips of all of the, the silly stuff that they say. I've not even got through this one yet. Level or the water level? Which one is most level to you guys?
Can I ask a new question, please?
Can I ask? Can I get somebody to answer a question? Which level?
The water level.
Go on.
Water level, Bill.
The water level is the most level.
The water level will show you level.
Okay.
If you'll take your auto level then to the center of this array of level points that you've established, set it at the center, and then shoot both ends.
Yep.
You'll find out that they're dropping.
What? Both ends of the water level lower than the middle.
We got a hump.
You've got a hump.
Absolutely.
It's a hump.
We got a humpus.
Yeah.
You got a hump face.
Nice. What about if you stood at one end? What happens then?
You'll shoot above the far. You'll shoot above the far one every time.
So that's a drop. Yep. Would you not get stuck at the middle bit that was higher?
It's a drop it would be a drop any direction you go. The Earth is always dropping away from you.
So the water, you think the water level drops away from you?
Yeah, I know it does.
Like a measurable from the horizontal, like you say, right?
The level surface drops down from the horizontal plane at a rate of 8 inches times the distance in miles squared.
That's Jesse Kozlowski, if anybody wants to know. That's Jesse Kozlowski that says that clip there. And that's why Blue's saying this, presumably.
If you'll do what you said, set your auto level up at the center and shoot both ends, or set it up at either end and shoot to the far end, you're going to find out that it won't match the water level.
Right, so it's a drop. Now, can I ask you, because you sound like you're a bit knowledgeable, what do you call a change in vertical in surveying? Like if there's a vertical distance change, what's that called?
It's elevation, and it's measured from sea level.
Yeah, you've just said that the
And all of
water
them-
level changes in elevation from the point
The
you're
water
at.
level does. Yes, the water level will. Absolutely.
Yes, the water level will. Absolutely. Says Blue Marble Science.
He trapped himself.
Yeah.
He had to say it.
Yeah. The water
And
level
they have
drops.
and they have a concave hump
Oh, well.
from both sides.
Yeah. Yeah. Well, I'll get to that new one, but I just want to establish that Blue Marble says that the water level drops a vertical change over distance, and that's known as an elevation change. He even knows it's called an elevation change. That's what
And what about the
Blue Marble does for
vertical?
you.
And what about the verticals themselves? Are they still parallel to each other?
Well, in surveying, they'd have to be, right? You can't have a leaning rod. You can't have the guy leaning the rod, can you? Otherwise, it wouldn't be vertical. You wouldn't be getting the shortest distance.
That's correct.
I mean, the
Would that mean that-
perpendicularities proved easily.
Yeah. Would that mean that it's parallel to you, correct?
It would be parallel. Well, it would be perpendicular to the horizontal established by the level. Every vertical, every time you hold the rod for a measurement, you want to be a vertical height. You have to be. And that vertical would be established as being perpendicular to the horizontal plane. I mean,
So do you think it would be fair to say that even using a theodolite, for example, with the crosshairs, no matter how far away the vertical is, it's still parallel to you. You'll still measure being parallel to you.
well, I mean, a theodolite isn't an auto level. An auto level establishes a horizontal plane. A theodolite has a scope that moves up and down, as well as around and around. And on the azimuthal, it also moves it up and down on that eyepiece.
I understand. My question is, if you were visualizing something on a vertical, something is plumbed 1 mile away or 2 miles away, as long as you can see it, would you still be able to detect that these on the same vector?
I'd be too far away for you to be doing that. All you'd be
Yeah, but
doing
you-
is
you
finding
wouldn't be able
points
to
to
see that-
triangulate.
Yeah, you wouldn't be able to detect any deviation from straight. That's my point.
Yeah, no. I mean, you're only surveying point to point, aren't you? All the time. Whenever you're surveying, to a point from the point that you're at, and then you're turning with. If you're thinking about a theodolite, you're thinking about turning an angle. That's all you do with the theodolite. I mean, there is a bit when you get into it that there's two different types. There's position surveying, and then there's elevation surveying. They're both sort of separate. You can be linked together now with tools, but they would have been theodolite and auto level, or theodolite and level. Hex, yeah, nice. Model Affliction Monday, Hex. This is globe surveying. Model Affliction. This is what surveyors are forced to say if they take on the model. Don't inject models into geometric principles.
Absolutely.
It's
wait,
not
wait,
establishing a level.
Wait a
Wait a
Hold
minute.
on
I think you might have got. Whoa, yeah.
Hold on.
Go on.
Hold on.
Take a mulligan on that one. Let's try again.
Don't overtalk.
Yeah.
Don't overtalk me.
Don't Penrose
But
yourself.
the water level is going to establish the same elevation at every point.
Okay, so it's not a measurable drop from the horizontal then, like you just said.
It certainly will be. It certainly will be. The water level is not measuring a horizontal.
A measurable
Water
change
level
from
is
the
measuring
horizontal
elevation.
is a change in elevation, isn't
geometric
it?
potential. It's measuring equal geometric or gravitational potential.
So it is a drop, and it's a measurable drop from the horizontal, which means a vertical distance change, but it's not a vertical distance change because the elevation stays the same. This seems a little bit tricky for you here, Blue.
I think you're double speaking, Bill.
No, I think that was you.
Did.
I think you're double speaking.
No, I think
It was your word.
you're conflating elevation with curvature, surely.
He was a humpist a minute ago, and now
Elevation
you
is
turned to
always-
a droppist.
It is not. Wait a minute. The elevation from the water level is always going to be the same.
You look at the chat. I posted again.
Right. Good old days. Blue getting conflicted within what is an elevation change and what isn't an elevation change. It is strange, because if you don't have the level as an elevation change, then you have to make the horizontal rise, which means you put a slope to a horizontal. That's the contradiction. I don't know whether people have realised that all of this. We've been saying it for quite a while, but I mean, the contradiction isn't drop or hump. Contradiction is if you have a drop of the water level from the horizontal and that not being an elevation change, then your horizontal has to move up, which then puts a slope on a horizontal, which means you're contradicting mathematics that says there's a zero slope. That's how simple it is.
They need to assert that even though it's curving, it's at the same elevation.
Yeah. Which then still makes a difference between that and horizontal and puts a slope to horizontal. Which you can't have a slope within mathematics. Everybody knows horizontal's a zero slope. It's the x-axis in a graph. Lays the foundation. That's what a horizontal is. And any drop from that is an elevation change. Hex says, but then he just waves it off as a contradiction when there is no contradiction. Well, there is no contradiction in reality because level and horizontal are the same thing in reality, observably so, geometrically provably so. It's fine.
Absolutely.
I don't have this model affliction. I don't have it to dictate to me anything about that. I can just live in reality and accept things as they are. Look, X. Yes, extended horizontals are sloped, he says. Extended ones.
Oh, really? What about the short ones?
Oh, right, I'll go carry on. I think it's Annick's about to do it. But yeah, that's a good clip of Blue showing the confusion that you put under. You as soon as you make a statement, you have to take the statement back.
So they're saying that the size of the line establishes if it's a horizontal or a curved line.
The U.S. Geology Society has measured this river to be 8 meters higher at the mouth than at the source. Over 550 miles.
Wouldn't the source be up the top of a hill somewhere?
So hold on, it's 8 meters, yeah? What about, so how far is that? 500 miles?
550 miles, yes.
Well, how much curvature is in that as well?
The curvature would be...
It's more than 8 meters.
Being an orientation perpendicular to Plum, that'd be over.
Oh, get out.
Perpendicular to Plum. Even Zanuck, you said it way back in the day. Geometric terms. Perpendicular. Plum, straight line. Perpendicular to a straight line would be level. That's what he says.
Yeah, it needs to have that 90-degree angle.
Yeah, they'll change the way they use the words now in order to not avoid themselves falling into the traps that they've done. But I mean, the words have been spoken. This is the model. The model dictates all of this stupid stuff. He's talking about the mouth of a river being 8 meters higher than the source, which is 550 miles away.
And it's flowing upwards, yeah.
Well, yeah, when you find out which river it is. This is some super water, super river.
Why are you saying that they're measuring the shape of the geoid? Why are you saying that?
Because they measure it with they actually have level. A handhold level can do this. They do it with sophisticated equipment to be able to show you that.
But isn't that begging the question?
Based on hold on, let me finish.
It's always begging the
Hold
question.
on, I've got a question for you, actually. Is that it?
Hold on.
Go
Based on the perpendicular orientation to plumb, that gives you the geoid shape.
There you go. Perpendicular to plumb gives you the geoid shape. You know what shape that means, obviously.
That's why it bends in the ends.
No, can't do, can it? The actual geoid, right? He's just told you that gives you the shape of the geoid. It's like the XY axis. You can think of it however you want to because of people giving you all sorts of images. But when they actually say it's perpendicular to plumb, that gives you the shape of the geoid, you've got a geoid
they cannot
problem.
say level or horizontal. Yeah, they need to say perpendicular to. Yeah.
Nobody's saying the geoid has any particular shape other than perpendicular to plumb dictates the shape of it. If you can put a
Seems
curve
very
there,
flat to me.
Yeah, if you can put a curve there, then somebody's played a magic trick.
It sounds to me like a nice concession.
Yeah.
It sounds like a nice concession. I would take that victory, man.
Yeah.
It's a concession. It's a concession right there. Yeah. The surface is perpendicular to plumb. Yeah, we know that.
Yeah. Yeah, that's what we've been dealing with all along. You listen to the words. It's like I said, they're wannabe wizards that have been taught by wizards, but the wizards never taught them the trick, right? They never showed them it was a trick. They just taught them it as though it was real, and they've accepted it. They can't see what they're saying because the trick's been played on them. They're in their mind. They've already got an outcome. Perpendicular to plumb, to them, has a shape. It's founded on nothing, but model dictates. This is good for this.
Now, let me read it again, but I think you can read it on your own. It talks about this image above shows the actual height measurements made along the banks. So they measured it actually. And both ellipsoidal and orthometric heights are shown. That's the green line and the blue line. The river that flows northeast has an increasing ellipsoidal height, along its length, which means it flows uphill in an
8 meters.
This is because the ellipsoidal heights don't account for Earth's gravity field. We consider orthometric heights, which do account for variations in gravity potential. We see the heights decrease toward the mouth. As we would expect, the water flows downhill. Does that make
so
sense?
the water doesn't flow uphill then?
I've got a question, right? Hold on, Zanuck.
It flows downhill gravitationally, but not ellipsoidally.
Right, okay, so what?
That's a new vector now.
Wow.
Gravitational vector.
Yeah, water flows on the, what's that? The ellipsoidal vector. Okay.
Yeah.
Due to gravity, water is going up.
Well, the river he's saying is the St. Lawrence River. Now, the source of the St. Lawrence River is the Great Lakes in Canada. Now, he's trying to say the mouth of the St. Lawrence River is 8 meters higher than the Great Lakes.
Yeah.
On his model.
That's going to be a problem.
His model has told him to say that, right?
He also has airplanes flying backwards, so I wouldn't be surprised.
Yeah, I know. But I mean, this is one of the people, like, one of the first meet and greets that you get when you come into this arena. Are people like this that are saying such. I don't know what you meant to do, really. Like, hello.
And they sound like they are authority in the subject.
Yeah. Yeah. Yeah, he'll like confidently say stupid shit. Like, because just his model dictated it to him. You'll have to ask Hex. You'll have to ask Zanuck. This is Zanuck's river. He's saying it's the US Geological Society that have done this. You'll have to ask them. Tell him Zanuck sent you.
What about the distance of 500 miles? Yeah. Do you know what the actual drop is?
Of course. What do you mean? They know? Of course, they know what the drop is.
It's 31.7 miles.
Right.
Right. So, which way is it dropping? What end of that river?
You're confusing
the
elevation.
high end or the low end?
You're confusing elevation with drop.
Okay.
You're confusing
well, there is a
elevation
drop.
with drop.
Yeah.
Elevation is what we're talking about here.
It's the curved level, isn't it?
Elevation is above
water's
sea level.
level.
Yeah,
So
exactly.
water's running.
So you're
down from the
confused. So in
hills.
other words, you're confused. Is that it? Is that what you want to? How you want to end this? You're
No, we
confused?
just don't
Do you
swallow
mock-
the
do you
shit.
mock what you mock what you don't understand?
So is that... Sorry, Zanuck, can I just get that? He's just give us some numbers there. Like, it wasn't you that gave us the numbers. Spot on did,
I
then.
did
But,
give
like,
numbers, yeah.
that's 300 and something over 5...
That is the spherical drop. It's
Right.
different than
No, that's the curvature of level, isn't it? Isn't that how much level curves?
Yes.
On your model?
Yes.
Right, why did... There you go. They can measure a curvature of level. Right? With a drop number, a vertical distance change. To them, can measure a curvature.
With calculus, I suppose.
Well, when they say measure, I presume, like most people, with a ruler. Like, you actually measuring. I don't know any other way of measuring. It's like it's a physical thing, isn't it? When you are measuring something, you have to physically do it.
Yeah.
Should be.
Anyone should be able to go back and use the same method and get to the same result.
Yeah. Yeah, something that you can't just calculate and wave about in the air. You have to physically show a measurement. Otherwise...
And measurement is singular, it's not plural.
Yeah. Show it. And I'm on board. I mean, we have been... I can't remember how long we've been going and asking them for any method for them to show this sort of stuff, and we'll have a go at repeating it. We're all into tests. There's quite a few of us. We've got a fair bit of kit available. We can do anything that we really require. We've done a few of our own tests. We'll be doing some more.
That's why we're all here, isn't it?
Yeah. Obviously, it's never going to come from these guys and the test, because some of the stuff that they say is there's a drop, but it's a not drop somehow. They have to switch it. It's crazy. Model dictates.
Refracted drop.
So what?
They have also problem with refraction, because if the level, curved level is refracted, it is straight again. So they cannot detect any curvature anymore.
Well,
So
I've got one video to go over at the end, because most of this sort of stuff that we've been going over here, we're just purely talking about the geometric stuff, no optics or anything involved in it. But obviously, these tools that we're talking about to do this, you have to look at them, right? You can't do this blind. So you have to use your eyes to look at them, but there is a working range that you can do that. And at the end, we'll bring in the effects of the globe surveyors and actually what happens when you try and do this stuff over distance that's not, and also a little bit of globe contradiction. All globe affliction added into the optics. I don't know how much more I'm going to go on.
On have to give us that number. Why couldn't you do it?
Because it sounds crazy.
No, it doesn't sound crazy. I already told you that before.
Hold on, guys. Let me read something that also sounds crazy. So if you look up geoid, and if you're not thinking about trying to win an argument, you just read it. Just read it. You say, geoid. The first thing that comes up, the hypothetical shape of the Earth coinciding with the mean sea level and its imagined extension under or over land areas.
Do you hear that as well?
Yes, imagination.
Yeah, well, the extension means sea level. Right, so that's you imagine what shape you want from that. That's what the geoid is. This is wizardry. They're giving you the building blocks for you to make up your own mind for what you want to happen.
Yeah, but they're trying to redefine things, aren't they?
Yeah.
They want that sphere no matter what.
Well, nobody said sphere, other than the people that imagine it. It doesn't say sphere in the definition. It's
Not
the
at all, yeah,
hypothetical
correct.
surface, as the extension. I'll put it back a bit. All right.
That also sounds crazy. So if you look up geoid, and if you're not thinking about trying to win an argument, you just read it. Just read it. You say, geoid. The first thing that comes up, the hypothetical shape of the Earth coinciding with the mean sea level and its imagined extension under or over land areas.
So what's up with that?
Yeah.
Again, it's just like that other one.
First time.
Yeah.
Yeah, I missed it the first time.
It's just like that other definition, isn't it? Perpendicular to plumb. I mean, imagine what you want, but that's not what they're saying.
He's saying the first word, hypothetical.
Yeah.
It's like pseudoscience.
Yeah.
It's like, that's crazy.
They're telling you. I mean, it's the first thing they let you know exactly what it is.
Yeah. Yeah, you just have to be able to cut through it and not have that model affliction. Like, look at it free from that.
This spheroid, or the ellipsoid, that is definitely under the mountains and over the base of the bottom of the ocean. It is a mean sea level. That's what it means.
Sounds pretty tame from
it's a picture.
Bible. That's crazy as fuck.
So you got an understanding now of what a ellipsoid is, what a spheroid is, and what a geoid is. This is real knowledge
It's
here.
all begging the questions, Anik.
It's not begging, we measure it. We actually measure it.
Oh yeah, it's measurable.
No, it's not begging any question.
Spot on gave us it.
Let me read to you again then. Hold on. So, although
We started off with a globe.
Let me read it. Let me read.
And
Hold
then
on.
you do the maths to see.
Although a chosen surface is truly the datum, it has become common practice to use the term vertical datum to mean the entire system, including the reference surface. surveyor marks.
Reading from which book are you reading from there, Zanik?
Used to determine the heights relative to that surface.
See, vertical datum. That means you can you can establish a plane on one coordinate.
Yeah, but they've ignored everything that's been said. The very first word that was actually highlighted by I think it was Elijah that was reading hypothetically, not real.
Yeah, but in reality,
all the sentences that follow up is considering it being a real thing.
Well, yeah, it's hypothetical because it's an extension above or below the land, right? It's obviously not there. Has to be hypothetical, right? But in reality, we do have a vertical datum. And all of those planes are established perpendicular to all of the plums, which gives you the ability to have what you call a vertical datum. Now, how do you have an elevation marked with one coordinate? I mean, how do you have one coordinate system? Have you ever worked that out? There's only one way you can have a one coordinate. Is that's establishing it on a vertical datum. Height above mean sea level. Established as a vertical change above that mean, wherever that may be. Of course it's hypothetical, because it'd cut through the land, wouldn't it? Zero would be, I presume, somewhere in the middle of the water level, because it's a mean. But then, like 10 foot above mean sea level would be a hypothetical surface. Like, it's just whatever you want to imagine. I suggest that all distances are measured on a horizontal and all elevations are measured on a vertical.
Yeah, because mean sea level is arbitrarily in the first place, isn't it?
Well, it's established over a mean, isn't it? So the sea level goes up and down. They just track it, and then they average it out to find wherever it is.
Arbitrarily.
Yeah.
That's why you would have different mean sea levels in different places, because it's arbitrarily after all.
Yeah. That's why they only have it at one spot. I mean, I think even because Canada and America are obviously so closely linked, that both of them take their mean sea level established from the Great Lakes and backtrack down to the level of the water. So then everybody can have their own, well, they can be evened out between the same. So they all take it from the same place.
Yeah, of course. I mean, I remember when I was little to learn that the oceans were at different heights. It wouldn't make any sense to me. Even today, it doesn't make any sense. It never did make sense. You cannot have oceans, bodies of water, being at different heights next to each other. It wouldn't work out.
Well, they do.
They need to be at the same level.
Well, no, they do change.
Yeah, but where they meet at the same level, they go up and down together.
Yeah, but
I'm not saying the whole body of water, but where they meet.
Yeah, they
where
do.
They meet.
Well, not where they meet, but I mean they had a problem because they were trying to do it in the UK, and they tried to do it in 3 different places, but they couldn't get them to measure up. They weren't the same. Yeah, so what they did was they went, we'll just go for one. Let's just have one. Let's just have that one point as the point rather than 3 different points trying to make it even out, because they can't. They'll all be different.
Yeah, but wasn't the Suez Canal built upon that concept that it's all level throughout?
Yeah.
That's why they united the ocean with to one another.
Yeah. But like I say, in the UK, we want to be exact. So you can't have mean sea level over there being 2 inches different than mean sea level over there, right? Which one is your mean sea level? You just have to go, well, they're different, so we'll just take one. There's only need to have the mean of one. But what they did then was they established, obviously, that they are different. When you try and do that, there's a difference in the differences, right? It means sea level established at different places will have a differing height. But you have to do 2 or 3 in order to be able to check, right? You have to cross-reference them. And that's what they did in the UK. I can't say it for everywhere else, but I mean, that makes sense that you only need one anyway.
Yeah, it should be just one. I agree with that.
Yeah. We'll carry on for this.
The book you're reading from.
I already see. You already see. I gave it to you already. And you didn't want to go to it.
What
this
the book?
Based on the NAV 88, and the what was the other standard? It goes back in 1980. The Geo 80 mapping. These are all.
The NAV 88 is the I think it's the North American vertical datum, which is good.
94? Is that what you were talking about?
None of this proves the spherical Earth.
People do this. Here we go. I'll put it's in the chat. Here's your proof. Go read up. Once you read it, and then come back to me what you don't agree with, because right now you're just mocking what you don't understand.
I'm just gonna have a look at it. What is this? Flash.
Who's the guy that says it doesn't prove things?
I'll be back.
Oh, I can't reach it.
Who's the guy that said it doesn't prove things?
Me.
So when did science say it's
and
good?
then comes up with math to make sense of observations in the context of a sphere.
Sherlock, where did science say it proves things? Because you said it like, you want to find this deep hole in science that it doesn't actually prove things. But where in science does it prove things?
Science doesn't prove anything. Science isn't in the business of proving anything. Proof only exists in mathematics.
Well, first of all, I don't think he was referring to science when he said that, but...
Yeah, I'll point out geometry is mathematics, and there are proofs within geometry. So if you're looking for proof, geometry is your best place. Like these guys are saying. They don't seem to think that there's a way to prove anything in science.
That was fight the tight shirt, right?
Yeah. And I think that's is that Chaiki, or I don't know who that is.
They are changing meaning of the word science, because science is knowledge. So in physics, there is no science in physical world. We have science inside us, in our mind. We use geometry, mathematics, and so on, and we gain science from thinking about physical reality. That's all. But thinking about science itself outside us is nonsense. But I think they are conflating this, because they say science, it means physics, but on physical world, that science would be in physical world.
Just throwing the word out there because it's a posh word,
Yeah, I mean, don't get caught up too much on they. It's only Zanuck, right? And they do say some really weird stuff. I mean, these are the extreme cases. I don't think this is everybody, right? And there's only a special few people that are able to say this stuff. Most people wouldn't. Obviously, no professors or anybody like that would ever come down and say this stupid shit.
I'm sure you heard Zanuck saying about space plumb bobs, no?
Yeah. Yeah, well, every down is an up, just waiting to be. Anyway, even you don't need space for that. Down is every direction. Rumpus is differing angles of down.
Down becomes up at
Yeah.
a certain point. Up never becomes down.
Yeah, but if you can go up to a place where there is no up or down, right?
I guess.
I guess we need to put Zanuck. We need to put Zanuck and Rumpus arguing this then.
Yeah.
Let me simplify this for you guys. Every down is an up waiting to happen.
Yeah. And every up is a nothing eventually. Turns into no direction. You don't know. Only lasts for so long. Mass dependent. That's the new one at the minute. We'll get into that. The geometric contradiction of vertical on a globe. The many contradictions of vertical on a globe. I think we could do that, couldn't we? Yeah.
Science doesn't prove things because that's not the business of science. Science is not about proof. Mathematics is about proof.
I think
Isn't this a scientific discussion? Does science debunk something?
So science doesn't prove anything. That's your position. But you guys know that the Earth is a sphere.
It's a reasonable understanding.
Without any proof.
Mathematical representation of what we measure. We measure it.
No,
We
they
measure
have.
it.
That's just it. Just admit that it's
measure
your
it.
best
Dude,
guess.
dude,
It's your
Ram,
best guess.
can you
And
prove?
Proof only exists in mathematics.
About it. That's all
Can you
you've
prove to me right now that, for example, your hand has 5 fingers? Can you give me undisputable proof?
I can prove to you that 1 + 1 is 2.
I asked you, how do you prove to me that you have a hand with 5 fingers?
I'll tell you
Whenever
how.
a guy went for a photo.
I come and I meet you, and you count how many fingers I have. That's
Really?
That's possible.
you could put
Whereas
I
traveling
got the
through
answer
space
that was.
is not possible.
I got the answer that would satisfy a Glober.
Go on.
1 × 5 = 5. There you go. Proof.
Proof only exists in mathematics.
Ooh,
So
Elijah, to prove something then, as long as you can verify it, that's good enough for you. You don't have to verify it, but as long as you can verify it.
You see, Elijah, even if you look at it with your eyes, that is not proof. Because I can't see air, for example. That means air doesn't exist.
Right, we go to space.
I know. That's why I said. That's why I said you would have to.
Proof, then it's a sphere.
Well, the horizon's level, so stick with that.
That's why I said you would have to be able to do more than look at it. And remember, I said you
go
would
to space.
Then it's not proof
types
to
of
me.
different things to determine it.
You can go to
It's
space
not
and see
proof,
the Earth.
Elijah.
So that's it, proof.
It's not.
Science doesn't prove things because that's not the business of science. Science is not about proof. Mathematics is about proof.
The flat Earth community is toxic.
Yeah, but what you're asking me to
Is your
believe is
question
very
of
different
what is question?
than me believing that someone has 5 fingers.
No, I asked you for the
Because
proof,
somebody
not the
having
belief.
5 fingers is verifiable.
How is it verifiable?
You can verify it by literally. Hold on. In the same way that you can meet a person, can you meet the sun and study it? No, you can't. There's the difference right there.
Yeah, you could go to the sun.
That is a
in
difference. It's a
spaceship.
real difference, is it not?
You could go to the sun in a spaceship, but you die, but you could go there.
Okay, who's done that?
I'm not dying.
That was Mark Taylor. You can go to the sun on a spaceship.
You just need to make sure you go at night.
You die. He's always invoking death.
Yeah. Well, there you go. That's enough for that one. I'll find another video.
Thank you. That was terrible.
Yeah. So that's them admitting that there is no proof in science. There's only proof in mathematics, i.e. geometry. Especially when you're talking about shape, definitely geometry, not numbers. That wouldn't help you. You've definitely got to deal with geometry.
Keep in mind also that Fight the Flat Earth, the guy that just said that, he also told me that a merry-go-round is 2D.
Yeah, but my question is, if we're not going to prove anything, what's the point of doing a systematic experimentation? What's that for? What's that all about?
Mm-hmm. Yeah. I think they're thinking that proof has to be positive, right? Whereas science is really based on falsification, right?
Yeah, but it's the same thing as the measurement we were talking about. You know? I mean, it needs to be repeatable.
Yeah.
And that's what science is all about.
In physics, you need to have experiment, and you have hypothesis and null hypothesis. If A causes B, it's my hypothesis is confirmed, and if A does not cause B, therefore I have proved my null hypothesis. But you have to perform experiment in physical world, real world, not in mathematics. You can calculate about this later, but you have to have demonstration. It means phenomenon. You caused phenomenon. You did something to something, and it caused something. Therefore, you have your experimental proof for something, or not. That's how science works in physics. So when he is saying Fight the Flat Earth is saying that science doesn't prove, he is incorrect, completely incorrect.
Yeah, but that's how easy it is, because what they actually mean is there's no proof of the globe, so therefore they have to do away with any proof, because they can't have proof for other things and not the globe. They have to get rid of it all.
Yes, but he is saying, in my opinion, he is suggesting, because these liars are very, very smart, so they are not lying overtly. So he is giving up with science in physics and is calling mathematics, but in fact he is talking about model, fantasy model. This what he is naming as mathematics is in fact fantasy model. Go to model and prove whatever you want. That's what I understood from his speech.
Yeah, but the globe model has been hidden under the umbrella of science. Yes. Now that we have a better notion of what science is, they are throwing the science under the bus. It doesn't prove anymore because it doesn't do any good for them.
Of course, they have to go to get rid of this because it's inconvenient. Experiment, you cannot perform any experiment. Therefore, you have to create model and in fact for example, new coordinate system, because Cartesian system, which is cubic in 3D, it is cubic system. In 2D, it is squared system. It doesn't work. They cannot prove anything, so they have to go to new geometry, which is defying everything we learn about logic, geometry, axioms, whatever.
No, it's not, because it still stays within the 2D conceptual realm. It never makes it into 3D, so you never actually have to imagine it being real, right? Only people in Discord servers that get model afflicted imagine that it makes it into the 3D world. Reality always stays the same. It doesn't change at all. And you can't change your geometry and make that change in reality. You can't just all of a sudden say that perpendicularity doesn't work like that on a globe model.
But they
The
are
thing is
trying
that
to do that.
the grid system that we're talking about, the globe model, was driven from a flat Earth model, which is elevation angles from Polaris. That's why the circles around Polaris giving us lines of longitude and latitude, rather than a square grid system.
The only one
Would be much
measurement that
easier
can
with
be
a square
taken.
one.
That is the only measurement that can be taken, really, over distance, other than on the land, right? On the land, a horizontal distance, you can work out elevation changes and all of that with distance over looking at the light in the sky. Geometrically, that's all you can actually do in reality, which is where we're going
it's
to
the only
next.
reference point you have.
Yeah, because now, right, with Blues just said in that other one, and Zanuck, I mean, that other one's classic, it goes on, and Zanuck does LIGO or Slack. But going on from that is the slope of the horizontal. It leads to a spherical level and then a sloping horizontal, which leads them into a massive problem, because surveying in reality is an actual thing that uses straight lines. There's no getting around
Is that why?
God.
Is that why it's called planar surveying?
Yeah. Yeah. Local as well. All surveyors survey locally survey with plane surveying tools. In fact, all tools are plane surveying tools. All of them.
So there is no tools to measure the hump then?
No. There's no actual geometric way of measuring a curvature. You still have to measure a straight line. That's the problem that occurs. There's so many contradictions, because all of this comes down to the measurement of a straight line from point to point. 2 points and the shortest distance between those 2 points. That's it. Game over.
I think it's quite simple, actually. Yeah, you just said it. It's quite simple. It sounds simple.
Yeah.
It is simple.
It's too
There's nothing
simple.
complicated about it.
Yeah.
Yeah, too simple.
Too simple, because people will be imagining it can't be that simple. Well, this is the problems that they occur is with surveying, and the problems that occur with this. I mean, this is the next one. Glow model dictates George and the double rodding, differential leveling. This is a real thing that people can do to check out that surveying works.
Let me comment on the last thing. People don't want to admit that they've been fooled by something so simple. They can think about it and know how simple it is, but they don't want to admit, that pride that they've been fooled by something that was so simple in the first place.
Yeah, paralogisms that have been placed there that nobody ever looks at, and people get upset when you point it out. Not that we want to get upsetting anyone.
Rather accept it than let it go and admit you were fooled. It's crazy.
Yeah.
It's crazy.
It is one of those things, though, isn't it? Like, once you see it, your eyes open up and you sort of I don't know. I suppose there is a couple of ways you can take it. But I mean, once you see how ridiculous this model is, then you have to drop it. And there's no way you could go back to it, I don't think. I don't think you could ever taste that steak again. I don't think you could ever eat a globe steak.
Some have.
Do you think?
Well, I don't think I know. Some have tasted the steak. They went back to the steak. I could name them.
Well, I'm not too sure they ever left the steak.
Like that's another question. Yeah.
I think that he was just doing his YouTube channel, and whatever side he took, he just did it for money. So when he just flip over, this was not problem for him. I was surprised, but some people do.
It didn't work out for him. He moved on.
Yeah. Good luck to him. Go doing well. Right. So this is slowly working through the claim to be surveying, but not surveyors, because they'll all claim that they have no surveying qualifications. Unlike me. I mean, I do have a basic land surveying.
But hold on a second. Do we need to have qualifications in order to ask questions or not?
No, I'm just saying that all of the people we're going over here are claimed to be authority on the globe side for surveying, but will also tell you they have no qualifications for this. So they are claimed to be the authority with no qualifications in it at all, which is a bit tricky to me, I would say, to be claimed authority on this particular matter. But I mean, I'm thinking that they're the authority on the globe surveying, which obviously can't be anything like normal surveying, because normal surveying doesn't support a globe. Even they do sell you that.
So basically what you're saying is these people, they just have an opinion on the matter. And an opinion, anyone can have an opinion.
Clouded opinion, right?
Anything.
Yeah, but
a clouded opinion, yeah.
Absolutely. They wouldn't normally be speaking upon it other than their model tells them that can't happen on the model. They've been triggered into it. Like I said to Betty and all of that, this sort of stuff is reality stuff. I'm not claiming it proves a flat earth, because it definitely doesn't. I mean, this sort of stuff proves that the earth isn't flat, to me.
I mean, I would go a step further to say that most of these people wouldn't say the things they say if they were saying it in front of people, in public.
Yeah, well,
they wouldn't say. They wouldn't dare to say, because it's so stupid to say. Yeah, correct. They say it because it's Discord.
Yeah, they're too scared to come and say it to us. So, I mean, that's why we're going over old videos. This is what they did say early in the day. But now they've learned, in order to not say this, they just have to not come round and speak. Because they'll have to say this stuff. They'll have to defend this. This what we're going to go over now. A few of these to get through. You're just telling us you don't care about level being horizontal. That's not an issue. But we are definitely on a curved earth. Like, level is curved, you're saying, right?
Yes, it is.
Right, there you go. So you don't care about one, but you do care about the other. That's
I'm saying we're not going over that scenario right now. We're going over the scenario of a curved earth and the fact that level is following the curved earth. The surface of water is curved on the curved earth. That's the scenario we're going with. That's what you have to understand in order so we can get through to show you the errors you're making and why your conclusions are wrong and why the method you're using is not going to detect the Earth curvature because you don't have enough resolution in your auto level and your range poles to detect the Earth curvature in the double rod differential leveling scheme. It's impossible with the equipment you're using to detect the curved Earth. Curved, level surface on the Earth. This is the surface of water.
There you go.
Resolution. You don't have enough resolution.
Yeah, you don't have the resolution to notice the
No,
curvature.
hold on a sec. Did I have it right? He
Yeah.
was saying you need to let me beg the question my way in order for all of these other things to work. Otherwise, I'll be in trouble.
Absolutely. Yeah. Axiom 1. That's what you've
So
got
he's
to
telling
start
him
off
off.
with. Yeah.
I mean, it makes sense. I mean,
Yeah.
why is he not letting him beg the question? I mean,
I don't know how long this is. I think this is a big long.
Never mind, Beth.
And I know exactly what's on your mind.
All right, this is
your playbook, it's all right.
not going to go anywhere. I can see that because.
Come on.
I was going through the LIGO videos the other day. I just wanted to make sure where the motors were and this and that. I just wanted to make sure. So I forgot. How could I run into something and I go, how the hell did I forget this? We all know they're building an underground LIGO named Einstein. I think they named it Einstein, whatever. And a space one, right? We discussed that before.
Yeah, I remember that a little bit. Yeah.
Well, how did I forget this? They're going to build because they want to increase the sensitivity of the detection. So they want to build another LIGO with arms not 4 kilometers, but 40 kilometers long.
Did they say where?
No, they haven't chosen a site yet. No.
Gotcha.
As far as I can remember.
That's why they're
where they
adding.
want it to go.
They're adding a third arm.
Now you
inside
guys
one
can
of the-
imagine the implications of that, right? A 40-kilometer arm.
There you go. Can you remember that, Essie?
Was that part of the video?
Yeah,
I forgot about that, believe it or not. So long ago, I forgot about it.
I thought that was SE talking right now. They're adding that third arm inside one of the tubes at LIGO Livingston to increase the sensitivity. They said that's what it does.
Yeah.
But I hadn't heard about that long one.
Yeah, this is underground.
hold on a second. Hold on a second. Let's make the question for a second. If you have a sphere, regardless of the size of the sphere, if you have a sphere and you need to do this, 2 different vectors, perpendicular to each other, 40 miles long on a sphere, I mean, how deep down you needed to dig on the sphere to achieve this? How do you have 40
You can
miles
YouTube
long?
it, Google it,
You
and
couldn't
you'll
use
find
the
it.
surface. Yeah, you couldn't use the surface for starters because the surface is not straight. So for you to find straightness of 40 miles in 2 different vectors on a sphere, you need to dig way, way deep down on the sphere, I would say.
Well, how could you even imagine it? Like, you see the problems they have with horizontal. They have it sloping towards the center.
But they're not stopping there.
saying.
They're not stopping there. They
that-
want to milk the system for good. The next step after that is, of course, in space. It's going to be, I don't know how many kilometers of coverage. They want to do a LIGO in space, I kid you not.
Well, they can do whatever they want, can't they? If they get people to think it, talk about it, say it. Just
How would you establish a level curve underground? What would you use? Which instrument would you use to measure the level curve on the ground?
A plumb bob. I don't know.
Maybe a plumb bob, but you need to use it every what? Every couple of meters you need to measure because it's deviating, isn't it?
Yeah. You'd have to. Yeah, the only tool you can ever use is a level, like a laser. And that'd be straight. It's ridiculous to imagine there's a curve.
Oh, we can use what they had tonight, water.
How the heck did I
use
forget
water.
that underground
If they
LIGO?
use something. Sorry, man.
No, I was just saying, how the hell did I forget that? So much craziness. I can't keep it all in my brain. I'm glad you played that one.
Some of the old bits. I mean, there's another bit, I think, in one of the other videos again. LIGO. All of these things that we talk about come round in a big circle all the time. We talk about level. They say it's not horizontal. We say, well, what is it then? And they say, well, it's a drop. Well, it's a hump. It's a drop hump. And then we say, well, reference it to what? And then it's back again in a big circle. It never ends. From the water level to LIGO to straight and then slope, and then it contradicts itself round and around.
Take a trip to Polaris, come back down, yeah.
Have a look at it from a distance. Squint your eye a bit. Man, but I mean, again, LIGO always comes into this. When you want to establish what straight is, this is your reference. Again, for perpendicularity too. In both axes, but I mean, they're not too sure about it. I'd say it is both for the arms and supposedly the mirrors.
That has to be perfectly straight and level.
Yep. A long way.
I can't wait.
Down they gotta go.
Yeah. I can't wait, bro, for this one.
Yeah.
A disco ball with a local level, yeah. It's locally flat, they say.
Okay, I'm here. False alarm, I guess. I heard the igniter go on, but I didn't hear the natural gas ignite.
Okay, George. So,
Hello, George.
Yeah, good morning.
Hey there, Bev.
I heard you were up late last night doing some research on...
No, I wasn't up late. Not real late, no.
Oh, okay. But you were... you know, like, when you got double rodding, I mean, they might call it something different.
When I got what?
When you went researching, looking for the double rodding.
No, I didn't do any research. I just worked out the geometry.
Oh, right. You just had to think about it, right? You
Yeah,
understood.
yeah.
Okay. All right.
Yeah, I mean, I've been aware of the double rod differential leveling, but you know, I just looked at it always before, rather just really quick with the geometry and was satisfied with it. But this time I just sat down and looked at it in real detail, worked out the geometry to see what was going on in terms of angles and how the rods would read from various positions. And so I went into a lot of detail on it now, so I have a real good understanding of what's going on there geometrically.
That's a nice construction right there.
Well, you want to wait and see what he comes up with. I mean, doesn't take much to get this, but the idea of surveying and measuring a height of the land and moving your auto level to doing incremental steps, where you sort of leapfrog the rod all of the time to progress that line all the way across. Well, double rodding places 2 rods in between the 2 stations. So therefore you can look back across the rods and know that you have a shared straight line segment, right? You know that if there's any inaccuracies, it shows a parallel planes. But
this is what I was trying to describe before. Yeah.
Yeah, that's what double rodding is. It's an extra technique. It takes a little bit longer, but it's a lot more accuracy, and you spot any errors immediately on each turn.
Yeah, correct.
Yeah, but
because you're using it as reference points.
Yeah, you're using two points at all times rather than just the one.
Yeah, but once that he mentioned the word angles, I mean, that's it.
Yeah.
It's done.
It's
done
a
and
model
dusted.
affliction, right? The problem is that the shared straight line segments or parallel planes cannot happen on a globe model. So there's an instant contradiction, and this is why there are no globe surveyors, because you can't say this sort of stuff. If you were a surveyor, if you were a real surveyor, you wouldn't have a contradiction within double rodding. You wouldn't even see the need for a contradiction within these techniques. Only if you are model afflicted, which George is obviously. If George wants to come and do his double rodding thing again, I just wanted to get the LIGO bit in there. Right. I think we might go back to LIGO. At the beginning, when you say you worked out the geometry, do you mean you worked out whether it was Euclidean or non-Euclidean geometry? Wait, what type of geometry? Or did you just mean...
Well, of course, it's Euclidean geometry. Okay. It's plain geometry on a piece of paper. You know?
Okay, so when we refer to geometry, we're talking about Euclidean geometry.
Yeah, of course.
Okay, and only Euclidean geometry, right?
You'll
let us know if you ever decide to want to swap geometries.
This isn't real complicated.
Yeah, I know.
It's just
pretty simple as far as I can see.
You don't need to know much more beyond the fact of intersecting lines. Line intersecting 2 parallels give you equal vertical angles and equal opposite angles, vertical angles, these sorts of things, adjacent angles, transverse angles, how they all are related to one another when you have parallels that are intersected by a line, the same line. And then the other thing is knowing.
See there, he went on with the basic Euclidean concepts, right? Parallel lines, another line intersecting them.
Yeah. But then they're not straight anymore.
How to compute arc lengths given a radius and an angle of sweep. What is the arc length? And that's about all you need to know, and maybe how a tangent function is defined, but that's the extent of the mathematics. The rest is just working out the algebra and the relationships of the angles and distances.
Yeah, all geometry would be deemed Euclidean, and all Euclidean principles. Okay, George,
yes.
I'm not. I'm just. It's for everybody else.
This is just basically no more than high school geometry. They don't get beyond Euclidean geometry, plane geometry, plane, Plane, plane geometry. Not solid geometry, not analytic geometry, but plane geometry.
That's good. So that's how you've worked this out.
Yes.
Okay. So what you mean is you've worked the numbers for how double rodding differential leveling works.
Yes.
Okay. Brilliant.
because you have to look at it in both, in two cases. One is the simplest cases, or over on a flat plane, a flat Earth, as you say.
A plane.
That makes it real simple.
Yeah.
And then the other one is you have to work it out on a curved Earth and see what the differences are.
That's not Euclidean then at that point, right?
Of course it is.
No, you can't bend the horizontal and say it's still Euclidean.
I didn't say I bent the horizontal.
Okay.
Bent the Euclidean geometry, arcs are permitted in Euclidean geometry. You realize the simplest geometry is what the Greeks did, where they have a straight edge.
Yes, we know.
Beth, this is not going to work if you're going to interrupt me. I do not interrupt. I haven't been interrupting you.
George is on a bit of a snowflake here, but I mean, like, he's adamant that he's only using Euclidean geometry. That's it.
Yeah, but he already conceded. I would have stopped there and take the win.
Oh no, because George is going to give his presentation on how double rodding differential leveling works on a globe model. Right? He's saying all of this, but then goes on to have his model Affliction. Yeah.
But you should interrupt it there and say thank you very much. That's it. Welcome to Flat Earth, and the conversation would have died there.
It's not flat Earth, though. We can't say welcome to Flat Earth when it's not flat. Like, that's not the idea.
He did describe it like that.
No, level as being horizontal, right? But that's not flat Earth. That's just level is horizontal. The elevation changes prove it's not flat. If anybody wants to have a concept of it being flat when it's not flat, then there's a bit of a problem.
Yeah, but we're measuring elevation from flat, isn't it? Let's be real.
From horizontal?
Yeah, from the flatness.
From the horizontal?
Yeah.
That's the tool. The level establishes a horizontal plane. He's even saying plane surveying, but then saying that there's going to be a curve. Yeah, I say, well, that's what George is doing. He's injecting curvature into the Euclidean principles, but then trying to imagine that drop is the curvature. It's not an elevation change, which to me is even crazier. Like, he's still having the horizontal and saying, well, if we use the horizontal, then we have this is an elevation change. But then if it's on a globe, then we're going to have not that drop not being an elevation change because it doesn't quite work with my model. There's some crazy stuff that gets involved with all of this with the model Affliction.
He has to curve a horizontal plane. There is no other way.
Yeah.
He has to.
And that's definitely not Euclidean, right? That bendizontal could never be a Euclidean because it's a straight line. And you can't curve straight lines and say that's still Euclidean geometry. They can have a concept that that's what they're doing. Obviously, people like George can.
You can think of it, it just doesn't make it real.
Don't talk to me as though you're acting as though I'm stupid. I'm just telling you. I know book 3 in Euclid is the book about circles, right? We understand the geometry involved in this.
Okay, so why are you asking?
Because you're talking about a curved Earth as though it's Euclidean.
Looking at a cross section. If you take a sphere,
that's fine.
If you take a sphere and cut it with a plane, you get a circle, which represents the surface of a sphere.
See, he can't get away from it. It's these contradictions that apply constantly. He wants to have a two-dimensional surface of a sphere, non-Euclidean geometry, spherical geometry, and then cut it in half or cut it with a plane and then have a circle, Euclidean geometry. Flips and changes between the two.
Unless I missed something, but he mentioned the circle and then introduced the sphere. He only has a circle.
if you cut the ball, the half, you have two spheres. Yes.
Yeah.
In the middle of this ball, you have equatorial plane. So he's talking about this equatorial plane.
Yeah, and it opens up the chance for you to be able to see the radius, because that's the only way you can conceptually get to a radius, is by doing exactly what he just did there conceptually in his mind. He's letting you know that that's how he sees whatever he sees. He sees a sphere as a circle.
But now we are inside of this globe model, and not on the surface.
And we are
measuring the surface.
Yeah, we're on a two-dimensional Euclidean shape now.
That's a flattened model right there. He needs that.
No. He's on a vertical plane.
He needs that horizontal in the center.
No, he's talking about a vertical plane on a globe. That's what he's talking about. Yeah, a vertical plane. A spherical
the celestial plane.
No, he's talking about, on his model, an imagined vertical plane slice through his model. In imagining, like, because he's ended up back at Euclidean plane shape, a circle.
Yeah, but he has the sphere split in two parts, a north part and a south part.
Yeah, he's just put a plane through it, right? But as we know,
center,
any plane through the center of their imagined model is a vertical plane, isn't it? Containing all of the verticals, with none being parallel.
If it is going through the Earth, it must be vertical. Diameter is vertical for them.
Come in, Sean, if you want to come in and explain this model to us. I mean, we know how your model works. Verticals. It's a vertical plane, but we know you can't have a vertical plane. But it's a, you've just got to imagine on their model, if you can possibly conceive a vertical plane on a globe model. I know it's impossible because there is no vertical planes allowed. Do you know why there's no vertical planes allowed on the globe model? It's because there's no horizontal planes either. And if you were to have a vertical plane, then you could have another plane perpendicular to it. And then that would have to be horizontal. And then all the perpendicularity of all of the planes would then extend outwards. And you'd have to lose the model. So perpendicularity and planes that are associated with them are not allowed. So say goodbye. If you've got a model, say goodbye to vertical planes.
Because all verticals are meeting in the center of supposed globe Earth. Mm-hmm. So they, by definition, they cannot be parallel to each other.
And you can't have perpendicularity associated to a vertical plane on a globe model. Because there are no horizontal planes. I know it's a massive contradiction that you have with a model.
I'm doing extreme gymnastics to try to understand you.
Well, once you understand that there is no planes allowed on the globe model, because the globe model is a spherical model, there is no... And the concept of vertical on the globe model is to the center, which means there are no perpendiculars.
I think we're all missing something. A sphere doesn't have straight lines, regardless of the vector.
Mm-hmm.
It doesn't exist straight lines on a sphere.
Yeah.
It needs to have a what do you call a depression angle in every single vector. If it's a sphere. It needs to drop from horizontal in every single angle, every single vector.
Yeah.
So a sphere doesn't have horizontals, it doesn't have any straight lines. And you cannot measure angles, because to measure an angle, you need a straight line first, and then to cause the angle, you need a third point. So you cannot have angles on spheres.
Yeah, we're not talking about on, no. This is the problem. He said if you slice the sphere with a plane, then you end up with a circle. Right? Now, that's fine. You can do that to a sphere. That's all well and good. The problem comes when you try to put vertical and horizontal and associate that with the model. Right? We're not talking about on the surface. We're talking about in just a plane surface. Now, conceptually, you can have a slice of a sphere through the center, but you can't link all of those radii to vertical on a ball. It just doesn't work. But they do. And
imagine you have a melon or a
contradiction.
watermelon, yeah? Imagine you have a melon or a watermelon, yeah, which is pretty much a spherical shape, yeah, that is not very elongated. You cut it in half, and you put it both parts facing up, and you have those two planes. That is the plane that we're talking about, that you need to refer to for the angle measurements. They need to have a flat plane. Cannot be done from the surface, because the surface is not flat, it's curved.
Yes, but they, in their imagination, they think this plane is horizontal. But it cannot be, because whatever direction you slice the ball, it's always vertical, according to their geometry.
Through the center.
Yes.
Right. If you go through the center point, it's always vertical, that plane. Now, that being a plane and being called vertical means that you could have another plane perpendicular to it. But that plane that's perpendicular to the vertical plane won't have all of the lines perpendicular to it being called vertical.
Because they will have to be concentric all the time.
Yeah, it's a massive problem geometrically when you try and link that model to vertical and horizontal in reality.
Yeah, of course. I mean, if that was, let's imagine for a second that is actually how it is, yeah? I mean, the vertical or horizontal wouldn't mean anything, isn't it? If you are actually on a sphere, you know. On any position you would be, you would have a plane reference, at least where you are. So it could be on any vector, regardless, you know, it doesn't need to be vertical or horizontal. You know what I mean? Because it's a sphere, it could be in anywhere.
Yeah, that's the point. That up and down are every direction on their model, which I can't go with, right? Vertical up and down have definite directions for me. Not every direction. I can't conceive it to be every direction. And the consequence of vertical being every direction means that horizontal must be perpendicular to it also in every direction. And that just contradicts vertical and horizontal being orientations. You can't have it being an orientation in every orientation.
So in their model, if you slice this ball into two spheres, and you have created this equatorial plane, and you put the plumb bob to this plane, and this plane is vertical, your plumb bob is also vertical. So you have perpendicular verticals. Idiotic, completely.
Yeah. I think the problem is that we use different words to mean the same thing for different. One is a concept, and the other one is when we do it in practical word, in practical means. I mean, in geometry, they do different types of lines. Horizontal lines, diagonal lines, vertical lines. You just need the builder, the researcher, the person who's gonna perform the physical work to understand what he's reading and represent it in physicality. But he's not going to use horizontals anymore. The language changes to level. And he's not going to use verticals either. He's going to use plumbs. So even though it's the same thing in two different situations, one is the drawing board, the other one is the physical.
Yeah, practical application of it. Yeah, horizontal, level, vertical, plumb. They're both just
absolutely
the same things, just practical terms and the practical uses of it. Let's go a bit more.
That is Euclidean.
Yes. Yeah, so not view. Spherical geometry, right?
No,
okay,
no,
right.
Not whatsoever.
That's fine as long as we're understanding that at the beginning.
Yeah, I mean, you take a section of a sphere, you cut it with a plane, you get a circle. That gives you the outline of the profile of the surface of the sphere. It's a circle, and that's what you work with. And it's like, it's just a cross section, and that's Euclidean geometry.
Okay, I get that. Now, do you want me to wipe my board and then we can get on the board and you can walk us through it if you haven't got any drawings?
Well, if you want to do that, but let's just talk about it first.
Okay. If we get struggling, then I can access the board for you if you want, right?
Yeah, that's fine.
Good.
Well, you were asking me yesterday about the readings on poles. If, say, you step the poles 75 meters apart, and then after setting your two first poles on the foresight on the differential leveling, and then moved your auto level ahead 75 meters and then shot back on a backside to the poles, and you read, say, 1.330 on the first backside pole, what would I read on the other pole? That's
right. Okay, so that's good enough. George is admitting that we're using Euclidean principles to do surveying. That's obviously using straight lines, angles, parallels, perpendiculars. All of those principles apply when anybody in reality is doing any surveying, differential leveling.
Yeah, absolutely. He admitted that at the beginning. That's what I was saying.
Yeah. Yeah, I'm going through the steps of these people that are claimed to be globe surveyors, but they don't seem to be doing much globe. Right? It's just all conceptual in the minds. Whenever they talk about doing anything practical, it's all Euclidean and just like normal, using level being horizontal all the time.
Yeah, and he also admitted that they measure everything flat, and then they sit down on the board and they calculate for the curvature. He admitted that.
After the fact, yeah.
Yeah, it just wins, man. It just wins, man. This is concessions. Big time.
Right, and now this one.
You can do fuck all with an angle, and the fools who running away.
Buster. Right, so this is
Blue Marble can't science.
yeah. This is again, this is another one, but this is we're getting into the Larry Scott and the Globe surveying, but we're over at Blues again, I think, or this was Mobius. Shout out to Blue. I noticed Mobius. No, that wasn't RBD face Mobius. That was double rodding. RBD face is a different one. That was just differential leveling. So yeah, this one now is Larry Scott and the Triangle, which is another one of the Globe model Affliction must do. Globe dictates. Here we go.
That's a new name for
Everybody,
me.
I don't
never
know
heard about
why.
that name before. Yeah, good.
Right, go on. Here we go. Poor Blue. They must sense a weakness in him. You know, so everybody's going after Blue. We'd be better leaving him alone at the minute.
Things. So.
Well, yeah, I know. Yeah, but it's
he doesn't
like
shout as much as the others either.
Picking on him, right? Isn't it? Just because he's
an engineer.
Yeah, and like wrong. But I mean, sloping water. He does say some really stupid shit, I must admit.
Come on.
When you profess that you're right to such a degree that everybody else is wrong, and you contradict yourself regularly, that kind of opens you up for like as a target.
Yeah. Who's his advisor, Larry? Who do you reckon that is? You've not been telling him about the sloping water. That wasn't you, was it, Larry? Must have been embarrassing. I hope you didn't tell him about that.
Well, he did say that the canal, the water in the canal at LIGO slopes on either end by a foot. So I mean, he did say that, right? And he's willing to bet 10,000 on it. So.
I just point out that it slopes upwards by a foot. So it's at a higher elevation at either end than it is in the middle, according to the as-built. We might be able to get a guy over there with a spirit level to have a look, though. Hopefully.
Come on, it's comical, man.
Got another one there, have we? Another one of the land sloper.
Water sloper.
Water sloper, double on either end spot.
We led the new charge now, right? Because obviously the curvature's a little bit tricky. They've done that. So the drop, the hump, and now the slope. And I suppose it works with both variants. You can have a drop slope and like a pointy, like a pyramid-y sort of thing.
Yeah. There's the drop. There's the drop that's curved. There's the slope that's curved, and then there's the horizontal plane that's curved.
Yeah. And it's not like we've been through this before many times about them bending straight lines and planes and all sorts of stuff. It does get a bit strange, and it does get a bit monotonous, really, going over it, and at the same sort of time. But hey, this is what we do. I'm taking it. Most of that stuff's come from you and Jesse, Larry, right? You were the guys. You, Jesse, and the guy from Maine. What's he called? What's his name? Jeff.
Yeah, don't forget the ordinance. I agree with the Ordnance Survey UK. So
I agree. I agree with the Ordnance Survey UK with the maps.
Well, good, because they said right off that they adhere to the curvature of the Earth when they make their projections. So I guess we're good.
Did you hear that again? Clever little words. When they make their projections. Very cleverly said that.
Yeah,
I don't know whether it's sophistry or that's just a paralogism that he has to add in there.
He didn't lie. He didn't lie. We just didn't point it out that he actually pointed out the truth.
Yeah.
They add it in. Yeah.
They add it
We know
in
that.
when they make their projections. Like, not when they're measuring it. It's only when they make their projections. But those projections are onto flat maps.
Yes, but they have flat maps and they project it on the globe.
Yeah, I suppose.
Yeah, it's another concession. Yeah. That's why we're laughing, because it's a concession.
They say they apply the curvature.
So they say that there's the drop over distance, and then they see it through optics and say the drop's over distance, but they'll just account for nothing because they know the level's level.
On the maps.
Exactly when they say level and horizontal are different in the context of geography of the planet. They say that. And so we agree with you.
It's okay them saying it, Larry, but I mean, having no proof of it means that it's just baseless words, isn't it? Mean nothing.
Well, okay, but when I go out and measure it, somehow that's not proof. I don't know.
Sorry, Larry, you've measured what?
The shape and diameter of the fucking planet with proper instruments over 10, 20 miles.
Larry, we're just... Did you hear that? He's measured the diameter of the Earth. Larry has. That's clever.
Halfway through the Earth.
Yeah. It's good. But calipers or something. What do you reckon? What tool do you reckon he's used to measure the diameter? I mean, that's a definite statement, that, right?
I think that it was through Mariana Trench. It's easier to get to the center of the Earth, I think.
Oh, we had massive problems with that. Don't get to the center where down becomes up, and supposedly you go weightless. Well, Wally was telling us that you go weightless in both directions.
How would you know you're in the center? Is that a sign when you reach there, or
when down becomes up?
Oh, I see.
Once you start flying,
Yeah.
you start flowing.
Once you start floating, yeah, that's you know you're in the center. Apparently, Wally was telling us.
Floating in the iron molten core.
Yeah, in the center, yeah. Yeah. Fantastic. Just on about the water level. Right,
Okay,
just
and
the
I'm
level.
And I'm talking about measuring the fact that all vertical lines are radial to the planet, as easily measured. Yeah, just like the Ordnance Survey UK.
They're all perpendicular to the plane of the horizon, aren't they?
And you keep saying that, which just shows your lack of comprehension.
Well, that's how they are defined, isn't it? Aren't verticals always perpendicular to horizontal?
Yeah.
Okay, now aren't all horizontals parallel to the plane of the horizon?
No. You see, that's your inconsistency.
See, he's saying that's an inconsistency, saying that all horizontal planes are parallel to the plane of the horizon, which is how it's stated. Check the definition. Any dictionary. Check mathematical definitions.
This is inconsistent with his model.
Yeah. Those three simple facts. all horizontals are perpendicular to vertical, and all horizontals are parallel to the plane of the horizon, means that you can double check, and all verticals are perpendicular to the plane of the horizon. Always. It's a checkable fact. Just check.
They need straight lines for the globe. They don't have it anymore. They are denying all the straight lines.
Mm-hmm.
All of the lines are curved. You cannot have a radius with a curved line. You need straight lines for it. They're denying everything.
I want to point out that these people that we're talking to here in these videos, these are the globe surveyors. These are the people at the head, the experts for the globe side for this particular thing. And so easily debunked by somebody or anybody really with zero surveying qualifications. Just through straight logic. These things just don't work
They
that
have
they're
the
talking about.
qualifications. I mean, I just ask questions.
Yeah. No, I'm saying it's good, right? They can't answer it. They're not here. When was the last time you heard a globe surveyor do a presentation about how the model works and how they can get their proofs? Because, like Fight the Flat Earth said, mathematics has the proof, right? There's no proof in science. There's only proof in mathematics. So where's the geometric proof of the globe model? Where is it? Should be some, shouldn't there?
Yeah, if it's a globe, it's a geometrical, no?
Yeah, and within mathematics, so there should be proof.
Mm-hmm.
Where are the globe surveyors with the proofs of this model? They've backed themselves into a ridiculous position. They can't get out of this. And that's why the surveyors, the globe surveyors, have done a little runner.
They need to do that part that we call them out, which is you need to add it in. They've been called out. That's why they don't come in.
Yeah. Yeah, they've been called, like Rakir would say. I call bullshit, and they can't defend it. Why they've left the arena and left people like Zanuck, Blue.
They conceded that they added in. I mean, they said it all. They just need to understand the words that came out of their mouth to realize what they actually said, and that they will have to agree with what we're saying. They just might be too embarrassed to understand, to admit it, at least.
Yeah. Well, this one gets better. This one particular.
It is perpendicular to the vertical at a point, and if you move down range
Every
a mile,
point.
yeah, and they're all radial because vertical lines are not parallel. Yeah, just like the Ordnance Survey UK says.
All
Have you
perpendiculars
ever
to a
eyed
plane.
anything into the horizon?
All perpendiculars to a plane are parallel, though, aren't they? Larry. See, he goes quiet for ages. Perpendiculars to a plane are parallel. Geometric fact. Strange that he can't answer it.
I think that he realized. He started to think.
Yeah. I don't know why
kicking in.
Surely you would be prepared for these sort of things. I mean, can you imagine entering an arena to talk about surveying? Because that's what Larry is. He's claiming to be a surveyor and not knowing about the perpendicularity of vertical and horizontal. This is very strange facts, this.
don't they all claim to be something that they're not?
Yeah,
Like
they're all. I
the,
think they're all
you know,
actors.
the science guy, the professor, whatever. You know, they're none of that.
Yeah,
They're nothing of that.
You get handed out roles at the beginning when you come into it. We're like, where do you want to be? Oh, well, we're a little bit short on pilots just recently. But they, you know, the ones that took on the role of surveyor, obviously have decided that they don't need to be around here anymore. Not surprisingly enough. Here we go.
I think he said only good for a mile.
All perpendiculars are parallel to the plane. All perpendiculars are parallel to each other. All perpendiculars to a plane are parallel to each other.
Except that's not supported by measurement. So fuck off.
What? They're all perpendiculars to a plane being parallel. Larry says he's not supported by measurements.
It's a very strong claim, man. He needed to demonstrate that, man.
He said this is a surveyor, supposed. Globe surveyor.
Have you measured any curvature from left to right before?
It's not measurement. Where's the measurement in geometry, Larry? You use the geometry to form what you're doing, and then you use the measurements to apply the geometry to work out other things. Or to map that stuff. I don't want to argue, Larry. I like you having coming. I like you coming round. I always like to have conversations with people.
Larry, may I ask you a question?
Sure.
I was wondering if you agree with Blue, because we had a discussion, and we're talking about LIGO, and somehow we ended up in the canal. And Blue seems to think that the canal, the water, 2.5 miles, he says that following the curvature of the Earth, it drops a foot by either end. Do you agree with that? You want to make a comment on that? What do you think? Because you're a surveyor and all. What do you think?
That's in reference to the LIGO vacuum tubes. And
no. The water, not the tubes, the canal next to it.
The canal next to it. Yeah. The canal
Correct,
next, which is a constant elevation, and the LIGO tube is a straight line, tangent in the middle, and the elevation of the LIGO tube is not constant because it's horizontal in the middle, and the elevation at either end is higher than the middle, and the elevation in the canal is constant. So we have the LIGO vacuum tube, which is straight because there's a laser in the middle of it. Yeah, it's straight and not a constant elevation. Yeah. And
Understood. But the water, I'm asking you specifically about the canal.
Yeah, okay. The water is the 3,960 mile radius of the planet. Yeah.
So you would agree with Blue then that there's a dip of about a foot, what he says on either end, correct?
From the tangent in the middle, but the elevation is constant. The water elevation is constant, and the horizontal tube is a higher elevation at either end after the 1.5 miles. Yeah.
Oh, there you go. The canal.
I would like to ask you questions.
Say the canal. I'll just let us get this. The canal is a curved, constant elevation, and consequently, the horizontal associated with it rises at either end.
Yeah, correct. I mean,
he's talking about elevation to the center of the Earth. So he's talking about radius.
Yeah, no, he's talking about an extension of a radius, vertical, which he can then imagine goes to a center, right? It's all imaginary, but he's talking about separating vertical, horizontal, and level. Level is a constant curved elevation in his mind, and consequently, the horizontal has to rise up at either end. A line in mathematics, reality mathematics, with zero slope, he's just said, rises up at either end.
Yep.
Yeah, correct. It rises up on either end, meaning going on a different vector.
Yeah. It's mathematics denier, right?
The middle is sinking.
On a horizontal, like a... Yeah. Fantastic. How you can have a horizontal straight line with differing elevations. It's amazing. Larry Scott, Globe Surveyor. Tell us some more. I'm just looking at this as well. And Starcodder's in the chat, and he's just put in all of the drop numbers.
He should be also considered a stand-up comedian. Man. He's very good at it.
Yeah, Starcodder's put the Ruhif numbers in there.
Do you think it might be a good time to explain about the quadratic function as opposed to the linear?
Yeah, no. I mean, we'll deal with that with the Globe Surveyors. I mean, it's a bit complicated, that, isn't it? I'm just trying to go through the simple stuff. The quadratic function makes it really difficult for anyone wanting to follow on with the with the globe numbers and the drop numbers once you add in the quadratic. Like I say, Starcodder's just put the numbers in the chat. So whenever we did this 9 months ago, so this is done last year sometime. Go on.
Good afternoon.
So yeah, these are the drop numbers for the water level over distance. And these numbers are the vertical numbers from the horizontal. The distance. Vertical distance numbers from a horizontal at the beginning. So these are the actual elevation change numbers of a water level. But they don't want them to be a drop elevation change. Because it's a water level, and water levels have no elevation change. It's really strange.
Yeah, but you keep going back to the tube. Forget.
Okay, then any body of water at rest is a constant elevation, which is a 3,960 mile radius arc, just like the Ordnance Survey UK says in the graphic I put up, which quotes them, which you can quote specifically, and then tell me you agree with the Ordnance Survey UK.
But I think we have we're not communicating here.
Right, so here's the contradiction. The contradiction is if they give us numbers, which is a drop from horizontal, but then say the level is a constant elevation, a curve, then they must be numbers of the rise of the horizontal. Which horizontal has a zero slope. So how can you have a rise of a horizontal? It doesn't make any sense. You're left with a contradiction, aren't you?
Correct. And then you have at the other light on the other end looking back at you, and both of them see a hump in between. And they cannot have that. I mean, it's nonsensical what they're saying. They should know better, man. This is so stupid. I don't know, man. I don't know what to say.
Yeah. It's either way, with however you start with this. If you separate level from horizontal, then at some point you are going to have to bend that horizontal conceptually. If you want level to be a same elevation, then some weird concepts happen within the horizontal. A change in elevation, but a change in elevation being a straight line on a horizontal, it's
the same thing with the refraction, because if you have a refracted globe, therefore straight line, straight level, then you have to bend upwards horizontal line, because it should work that way with refraction. So they have a dilemma because they cannot resolve this problem.
Oh, I see what you're saying. I think I got what you're saying.
Because
if light would refract or bend the way they say, in order for us to see something that is actually straight to be curving into a sphere, imagine a lake surrounded by mountains. You wouldn't see it straight either. You would see it curving, but the other way around, because the light would have to curve upwards on the mountains. You know what I mean? So a light would be bending upwards, never downwards. We don't see it either way. We just see it flat plane. That's it.
Yes, generally speaking, if the curve line is straight because of refraction, therefore straight line must be curved. So horizontal is curved and globe is straight because of refraction. This is their logic.
Yeah, once you explode an explosive system of logic, and literally anything can happen. And the only thing you have to do to explode a logical system is accept a paradox somewhere. And that's it. You've lost your logical system. That's why there's nobody coming here talking. That's why there's no globe surveyors around. Feel sorry for
I think it has to
ballers.
do the way I see the way they describe it. The way I see it when they describe it is it has to do with the tangent. You know, the straight lines or the horizontal lines, they can only stretch on that position until a certain point. From that point onward, they cannot be horizontal anymore. They need to be curving. Problem is that it doesn't work like that.
You can't curve a horizontal. You'd be mad, wouldn't you?
Yes, of course. It doesn't work like that.
Yeah, it's very simple, but I mean, that's why there's no globe surveyors. There's no globe surveyors around, and obviously the only people that are left are the people that are severely model afflicted, that have imagined that the globe surveyors were saying something that they didn't actually ever say. I've been saying for a while, I think Jesse Kozlowski's a wizard. But he's definitely fooled a load of people, like Blue Marble Science.
Yeah, actually, this guy used the word planet, which is, you know.
A bit more. Yeah, elevation isn't a circle.
But I'm asking you specifically for the canal, the water. Blue claims because of the curvature of the Earth, there's a hump in the middle, and in either end, there's a drop by 1 foot. I'm just asking you, do you agree or not? That's all. I'm not
Okay.
I'm not poking you here. I'm just asking you a question.
Okay. Yeah, that drop is from the horizontal tangent in the middle, and the elevation of the water remained constant.
So there's a drop on either end, but the elevation remains constant. This is your claim.
No, you got to use the complete quote. It's a drop of a foot or more from tangent at the middle. It's a constant elevation, and the horizontal tangent in the middle is going tangent to the earth. And the difference from the horizontal tangent to a constant elevation after 1.5 miles is a foot, but the water is a constant elevation, and a horizontal line is not a constant elevation.
See, that's a supposed globe surveyor saying that.
Unbelievable.
He's got a nerve, right? Yeah. He's got a nerve. I mean, by the way he was saying that, did anybody actually think that's the way surveyors work? Could anybody be convinced that that's how surveyors actually work?
I don't think so, man. Maybe a child.
Maybe Rob.
Oh, well, I bet there's a lot of people who are willing to believe Larry Scott said that and he really meant it.
I'm kidding, Rob, by the way. I know you wouldn't believe that silliness.
See, Howard's in the chat here, in the YouTube chat. I bet he thinks that's what Larry says is real. Go on.
I was going to say, I think a real surveyor would use level and horizontal interchangeably.
Yeah. Well, they just use level, knowing it's horizontal. I would say, but I mean, no doubt the globe surveyors will be rushing in to come and let us all know how wrong we are. They'll be doing presentations, hopefully, over at Blue Marble Sciences about how this stuff really works and how wrong we are. I know they're saying it in the chat. I mean, there's Howard Moore over there. Long time no see, Howard. I remember when Howard used to pretend he was a surveyor too. Back in the good old days. Sorry, who is that?
Sorry, it was me. Sorry to ambush you. I'm saying it would be nice if they would come in. I would like to ask them a few questions myself.
Yeah, they're not coming back. There's no globe surveyors, and that's going to be proved by none of them coming to have a chat with you about it, how it works, or basing any of the fantastic claims that they're making. A horizontal change in elevation over distance. Genius.
You mean there is no globe, just surveying?
Yeah, there is no globe.
Plainly.
You just use horizontals and measure vertical changes from the reference. I mean, it's all pretty simple.
Yeah, it's called planar, planar, isn't it?
Yeah.
Yeah, there you go.
It's called planar surveying, and all surveyors survey locally, and that's where plane surveyors survey. Even geodetic surveyors survey locally, and they would be using tools like auto levels or theodolites or the GPS systems, and they're all plane surveying tools. They all do the same thing. Right, okay, Larry.
You mean the difference is that they need to add these numbers afterwards, yeah?
I don't know what they do afterwards. I just know that they measure horizontal planes and vertical changes from those horizontal planes. That's it. I don't know how anybody could... I'm not aware of how anybody could curve a straight line once it's been measured. Because it's been measured in reality, reference to that straight line. You can't just say, well, that was bent, I'll map it on here. That doesn't work.
That's what they confirmed that they do.
Who?
George, didn't he say it? First they measured it to be flat, and then they add the calculations in.
Well, but they don't even do that. Just conceptually, that's what they think happens. But all maps are flat. It's strange. There's no mapped curvature on those. The contour lines are all mapped as elevation changes, reference to a horizontal. Where did the calculations get changed? But it just doesn't happen, ever. Unless anybody wants to come and let us know how they add and change and add in calculations of curvature from none that's measured. But again, I don't think we will, because there's no such thing as a globe surveyor. And what you just said there, that George said, they just literally don't do. They can't do it. It doesn't make any sense why they would do that in any way. To me. Stark Odder, because we've been doing this drop thing. Have you seen the Ruhif numbers? But if you just check in the live chat there, we've got 16 100-meter water levels going off in the distance, and they're the numbers there. Now they've been checked by multiple people now. Stark Odder, he's the latest one, right? They are the numbers for the drop from one end of the water level, not the middle. So why do you put the some sort of a tangent in the middle? Why do you not start at one end like everybody else seems to do?
Because in Blue's comment that you asked me to comment on, it was in reference to the vacuum tube, which is tangent at the middle to the surface of the Earth. So
you mean
that's
like Lake Pontchartrain? I'm just trying to keep everybody up to grips, right?
Okay. You moved from a comment that Blue made, which was about the Lagos tube. Now you want to talk about Pontchartrain.
No. I'm just trying to get the drop from the start point, or versus the hump with the tangent point that you imagine in the middle, right? That's different, isn't it? Because you have to go from one end. You have to go upwards towards where you've got the tangent point.
No,
it's
not
a hump.
upwards. Not in elevation. No, elevation of the Pontchartrain Causeway is constant, and the elevation and the Lake Pontchartrain Bridge is a constant height above Lake Pontchartrain, and Lake Pontchartrain is a body of water nearly at rest, 3,960-mile radius. Yeah, we got that. No hump in the middle. What's wrong with you?
Yeah, there is. Jesse says it. There's a hump. Loads of people say there's a hump. McToon says the hump.
And he gives the number. Tell him the number, Bev.
Yeah, there's a 28.5-meter hump from the Sagitta, right? If you say Sagitta...
Yeah, okay, yeah.
That's a hump.
The cord from either end of the bridge is a cord.
It's not a cord.
And then the height...
it's not a cord, Larry.
Oh, no. Oh, you see, that's where you're mistaken, because it is. Yeah. The cord from either end of the bridge to the deck of the bridge in the middle, yeah, it does have that 28-meter or 28, whatever you said, Saga to the cord, to the arc. Yeah.
So you're saying the cord is the shortest straight line distance from one end of the bridge to the other?
Yeah. Uh-huh.
Yeah, but if you were stood on one end of the bridge then, you're expecting to see a drop, aren't you?
A drop from horizontal at one end?
Well,
point A. Because the bridge is a constant elevation, and if I'm at one end and I set up my auto level, my crosshairs will be looking into the sky, and the bridge will be going below those crosshairs because...
Right, there you go. He's now had to have a sloping horizontal. His crosshairs will be looking up to the sky.
Yeah, it would be nice, wouldn't it? You just did a roller skates on the bridge. You just go downhill.
Let him have both. Come on.
No.
Sloping horizontals are what needed
Yeah.
for him to have his bent level. It's crazy the concessions he's making. Does
Unbelievable.
anybody here at the minute think Larry Scott is an actual surveyor? How easily he's given up level and horizontal. Like,
I think
what's
he's
going on?
impersonating one.
Badly impersonating, right? It's what the globe model requires. And Larry's just maybe just simple enough to say that stuff without realizing that there are actual professionals that do this job for a living.
I think he just thought for himself that no surveyors were into this debate. So he impersonated one, thinking that people would listen if he would say that he is a surveyor.
Yeah, because then
If
the
so, it didn't
globe
work out
need
for him
it.
very well.
Yeah, the globe need it because they need people in authority to tell flat earthers that they're stupid for asking questions. I mean, it's ridiculous the lengths that the globe have to go to. And again, Larry, you're being called on, right? This is ridiculous, and there's no way you can defend it. We know that, but not me. These people aren't able to talk to me. But there's other people that want to have a word with you, Larry. Not just me. So if you want to come back out of hiding, come round. There will be people here to have a chat. They have questions. Sloping horizontals, curving levels. All seems
Negative
very
hump.
strange. Yeah.
Because the bridge is at a constant elevation.
How far
and
will you be looking with this instrument, though? Like just your 100 meters maximum or more?
the 100 meters or so is a specification for where the curve and the drop and the horizontal are so similar that it's not of much consequence. But if you set up your level,
just to read it accurate, that's what I've always worked on when I'm using them.
that's why to maintain the accuracy, you pick after 100 meters, you pick up your instrument and move ahead so that the curvature does not accumulate and make problems.
Definitely wouldn't look at it, for over a distance of more than 100 meters. Otherwise, it's going to be inaccurate. Yeah.
Well, you'll have to take other considerations if you're confronted with a longer measurement. But by the basic procedure is, you keep moving your instrument along so that your local horizontal tangent and curvature are so close to the same. It's a small, almost no consequence. Yeah.
Right. This is one of those moments where we have to bring in the quadratic function. Now, the quadratic function keeps changing the further you get away from the start point. If you keep moving, like he's talking about here, you never really get a chance to employ the full quadratic function of it. And then that negates the quadratic function, which shows that the quadratic function is actually impossible when you try and translate it to reality. Geometrically, it can't occur that quadratic function gets used. Sort of impossible. I can try and explain it if you want to come round it, but it's not really to be done live, this. I don't think that explanation of the quadratic.
Yeah, I'm not sure what you mean. Yeah, I have no opinion about it.
Yeah, I'll show you some other time.
But if you're going for the very high, or if you're confronted with very long distances, then you use angle measurement, theodolites, and the shape and dimension of the planet then becomes very, very critical to your measurement to maintain accuracy. Yeah,
Surely
God.
if you just stayed the same distance off the water, all the way across the bridge, you'd be, you know, that'd be a level line from point A to point B, yeah?
I don't know.
If you measured that, if you were building a bridge and you wanted to level with the water and you measure down from the bridge each time you do a section, then, you know, you'd be level with the water, wouldn't you?
Yeah, just like the Pontchartrain Bridge.
So why is it you see this, you know, huge optical like anomaly, like a big bulge in the middle of it?
That's only because if you are looking from end to end and you have taken your theodolite and lined up on the far end, then you're looking along a chord of the arc of the Earth.
He said you're looking along a chord, but if you have a chord, then there's a sagittar in the center, and you wouldn't be able to see along the chord because there would be a massive obstruction. I mean, even what he thinks he's seeing, it's geometrically impossible. It's not. The words he's using aren't complying with, you know, what the observation would be if he were to imagine that he'd ever actually done that. I don't think if he had actually done that, he wouldn't be able to use those words, I don't think. Looking
no one is
along
looking
the
through a
chord.
chord.
That's ridiculous, isn't it?
It would be impossible to see that way, this Pontchartrain bridge, because it should be constant drop, not hump up upwards.
Yeah.
But on this picture, we can see that this bridge is going up and then going down. It's impossible on the globe because your point of your position should be hump, not in front of you. It's complete nonsense.
Yeah. And Mobius has put in the chat there, lol, what the fuck is a local horizontal tangent? It's ridiculous, some of the words that they end up coming out of their mouths. So, looking along a chord, fucking ridiculous and impossible. You can't do that.
Through the water, through the
Yeah,
earth.
yeah.
That'd be nice.
Why is that so hard for you?
Why is that so hard?
Because when I see the picture of the bridge that some people have put up, I've seen pictures of that bridge from side on and there's no curvature whatsoever. It's just a level bridge, level with the water.
Yeah, check out. I've just done it was a bit confusing, Larry. I'd never even heard a horizontal tangent. A low, whatever. It just turns out it's a line on a graph, on the horizontal axis on the graph. I mean, that's what I'd have thought it was, really. But, I mean, it doesn't seem to mention the Earth. I mean, you don't think that like, blue line on that thing there, you don't think that's the Earth, do you? I mean... Are you getting confused, Larry, with mathematics and stuff?
Yeah, that graph you put up is not the shape of the Earth. Yeah, okay, so what?
That's a horizontal tangent, though. That's what a horizontal tangent is.
You put up a meaningless graph, so I don't know how to respond to a graph which is completely out of context of the shape of the Earth.
How do you make it a tangent when you say horizontal? I say horizontal plane. And I say that all of those horizontal planes are parallel to the plane of the horizon. But you don't think that, do you? So how big is a horizontal plane that when you imagine it? Like, because even that's a line on a graph. It's a horizontal line. It's a tangent is a line. Isn't it? What are the dimensions of your... horizontal tangent planes, I take it?
I refer to the graphic the Ordnance Survey UK has provided to explain it to you. Bring it up with them, because I agree with it with my measurements and my.
So you don't have any of your own stuff. You just refer to a British.
No,
thing,
I was. You broke me mid-sentence because I agree with my kit and my observations and my measurement and my 35 years experience. Yeah, I find no disparity with the graph that they presented. And if I ignore any of the components of that graph, then I get wrong answers. And you know what? Follow the money. I don't get paid to produce wrong answers. I get laughed out of the existence, and that's why I'm a chartered surveyor licensed in states for the practice of land surveying in public works.
Wow, big claim from Larry Scott. Looking down.
What I heard him saying was, "Don't report me." You know, I need this job. I've been doing this for 35 years.
Can I ask you a question then, Larry? If you've done surveying and that, what's the furthest that you'll ever survey? You know what I mean? Like with your instrument, where would it, optical?
147,000 feet.
What, in one? You're looking across?
Yes, from ridge to ridge across the valley. Yeah.
And what tool was that? Sorry.
I didn't hear that question.
Sorry. Yeah. I just wondered what you used for that. Yeah. What tool was it? Okay.
Stand by.
What was the job? What was the purpose of you doing that?
Did he say 137,000 feet observation?
I think so. 147.
Oh, my bad.
Then I heard it right. Okay.
I think so.
Yeah, like Bev said, I just wondered what why you would do that. I mean, like, is it like you're planning a route for a canal or something, or
zip line?
Well,
that's quite handy because everything slopes away.
Yeah, zip line.
Zip lines are perfect for when you're looking through these instruments because it always drops away.
It's quite a long zip line, that though, isn't it? 147,000 feet.
Yeah, so
what's that? 5,600 a mile, is it? Ish.
5,000 feet to a mile. Yeah.
It's 28 miles.
Nice.
That's a hell of a measurement.
It's a good one, that.
But what for? That's the question, isn't it? I mean, was it just an observation where you just went out to see how far you can see with the instrument that isn't designed to look that far?
But it's not what for, because the moment he left was when you asked him what instrument did you use or what device.
No, he's here.
He hasn't left yet. He's putting pictures up, I think. That's good. Right.
Well,
He's showing us his equipment.
I've seen that tower a few times.
That looks like a fancy station there.
Okay.
Yeah, this is good. Larry's explaining now that this is what Larry's done for surveying. Seems to be the only thing that Larry's done. He does bring it up a lot. Have a listen to what he was doing.
Yeah, he's at a high elevation there.
Wow.
Right, so what was the job?
I was measuring the elevation of the radio tower at 27.69 miles away.
See, what he said there is he was measuring the elevation. You do not do elevation measurements at that sort of distance. You can do triangulation and stuff like that over those sort of distances, but not for elevation. That's ridiculous. I mean,
Yeah, I agree.
this is another big X against Larry's surveying credentials here. You don't measure elevations. There's trigonometric leveling and triangulation measurements. Listen to what he's saying.
And the only way that makes sense is with 511 feet of curvature and 80 feet of refraction. And
But again, only way that makes sense.
Okay.
Yeah, he's at a high elevation there.
Wow.
Right. So what was the job?
I was measuring the elevation of the radio tower at 27.69 miles away. And the only way that makes sense is with 511 feet of curvature and 80 feet of refraction. And I duplicated that measurement from only...
Right. Did you hear what he said?
So he was on curved line, but refraction straightened and up, and therefore he had straight line to this tower.
No, we asked him what he was doing, right?
He
And
said 20 odd miles, didn't he?
He said he was looking at 28 miles to measure the
28
elevation, and the only way that makes sense is if there's curvature, right? As if to say, the only reason he could be looking that far to measure elevation is if there's curvature. Well, you wouldn't look that far to measure elevation in the first place. So he's basically telling you that his model Affliction is that big that he's concocting ways to find the curvature that shouldn't be there anyway. That is, it's not standard practice. He's going beyond just because. Listen to it again. Listen to what he says.
Okay.
Yeah, he's at a high elevation there.
Wow.
Right. So what was the job?
I was measuring the elevation of the radio tower at 27.69 miles away. And the only way that makes sense is with 511 feet of curvature and 80 feet of refraction. And I duplicated that measurement from only 1 mile away. And in both cases, I get less than 2 feet of difference in the elevation of that tower.
But we do already know how tall the tower is, right?
No.
Right. Here's step 2. Right? He said the only reason it makes sense is if there's curvature. And then I say to him, they already know the height of the elevation of that tower, right? And he said no.
Yeah, but he's admitting, he starts his statement by saying he's doing elevation angle. And not only is lying, he couldn't observe this 28 miles away, this tower, no matter, not at this height he wouldn't. But he's saying that he needs a flat plane to do so. Well, he's admitting from the beginning. He's giving you a disclosure. His job was to measure an elevation angle from that tower at that distance, and he says that he can only do it if the base of that triangle is curved. I mean, it's nonsensical.
Well, I think you're reading stuff into it there. I don't think he said anything about the base of a triangle being curved because Larry's not that silly to say that or to try and imply it. He's just saying the only reason for him to do that, the only reason it makes sense for him to do it is if there is curvature, which doesn't make any sense at all.
I just want to know an elevation angle. Yeah, right.
But what he's saying is, oh, go on.
Who paid him to do this job?
We'll get there in a minute. But so I ask him, do they not know the elevation of it? He says no, and it's like, but it's a radio tower. Surely they've positioned it somewhere where it can get the maximum signal, right? They know how high that mountain is. They know how high that radio tower has to be on top of that thing. Like, the question comes, what's he doing? Like, why is he doing it? They obviously already knew when they were building that radio tower how tall it needed to be on top of that mountain to get whatever it did. So, we have to ask Larry again.
Obviously.
What the fuck are you doing?
I
You
measured
didn't
it.
know how high the elevation of the tower.
You see, you don't listen very well. I said I measured it from 1 mile away and the 27.7 miles away, and after applying the 511 feet of curvature and the 80 feet of refraction from 27 miles away, I get less than 2 feet of difference when I was only 1 mile away.
Larry, I don't want to seem as though I'm attacking you or anything, but we did ask you what the job was. So,
to determine the elevation of that light on that tower.
Did they not already know what the elevation was of the light on the tower? The people that employed you to work this out, right, as a job.
It was not a paid contract.
Okay, right. So we start again then.
All right, okay, yeah.
Can we start again, right? What is the furthest you've ever been employed to do this? You know, like using your actual surveying techniques, not newfangled ones that you've just made up that you do in your spare
those
time.
are not newfangled ones. Okay, the longest I've ever been dealing with is in 8 and 10 mile observations while surveying up and down the Santa Ana River in Orange and San Bernardino County, California, where we made major maps for dam construction and flood control. And yeah, it went for 50 fucking miles in 5 and 8 mile lengths.
What? And did you ever add anything up?
Right, so we've just changed now from that wasn't actually a job. It was something he was doing in his spare time to work out the elevation of a known elevation of a tower. I don't know. He was applying different things to. I don't know. Doesn't really make much sense.
Yeah, maybe was learning.
And then he says, actually, what he'd done was to survey a river and the floodplains for the area around. Now, everybody knows that a river's flowing water, right? It's going to a lower elevation because the water's flowing. So, where's the curvature in that? I mean, if it was flowing 8 inches down in a mile and he looked from the bottom bit upwards, would he say that's not flowing? It's all the same elevation because it's dropping 8 inches in a mile? I mean, who knows? Like, these are all questions that we would like to ask, but I don't know whether they're coming in or not.
Say if the river's running, did you add anything onto that river running? You know, like how would you actually, you know, like because we've been talking about the water level here for a while, and some people tell us that one end of the water level will be lower than the other part of the water level, which would actually mean that it would be running and not actually, you know, level. So, like when you're surveying a river, what were you surveying the river for? I mean, to see how much run is on the river.
No, because we know how much run is on the river by its elevation grade as it goes as it flows to the ocean, and we were making a large area control network for topographic mapping and engineering and land takes for flood control infrastructure.
Yeah, did you so your observations though when you were, you know, doing like when the actual surveying to try and get the actual, measurements. You did that using the normal techniques, within 100 meters or whatever you're doing to get the.
No. I said 5 and 8 mile section lengths, not 100-meter.
What? So if you're looking like down the river, and you'll see the drop of the Earth, you think as well? Is that what you're saying? In 6 miles?
Well, and the measurements also return that drop, that radius of the Earth. Yeah.
Well, so the river's dropping with the Earth as well, sort of thing. Like, because if you're at the other end, looking back to where you are, when you're seeing the drop, surely it's dropping the other way. Then what happens with the river then? Surely it goes up the other way.
Yeah, you can play that silly argument because
No, it's not silly. It's a logical.
It's a constant. Yeah, elevation is based against the radius of the Earth. So even if you have thousands of feet of quote drop from a local tangent, that does not mean it's thousands of feet lower in elevation.
We're in the UK here, Larry, and elevation here is above mean sea level.
Yeah, I know. Just like it is here.
So it's not reference to the centre of the Earth then. It's reference to the mean sea level. Average mean sea level, sorry.
And mean sea level has a radius relative to the center of the Earth. Yeah, I would see. I'm glad we agree with that. Just like Ordnance Survey said.
Do you see the little thing he did there? He showed his model Affliction. Did you see that?
He also mentioned a flat control. I would like to ask him when he does this flat control if he accounts for the bulge on the water.
In the river, like Spot On said, if you go the opposite direction and look up the river, can you also see a drop? Which, when you employ the quadratic function into it, then yeah, you would. You see a drop both ways. You have to. On their model. It's backwards. But Larry's
That's
just
where
showing.
they get paradoxed.
Yeah. Larry's showing he's been nutsacked by somebody, right?
They needed to account for the weight of the volume of water above the container.
Sorry, you say what? All mean sea levels are referenced to one central point. Is that really? I don't think that's right. I think they're all referenced to their own mean sea levels, aren't they? The elevations.
Yeah, and mean sea level in England and mean sea level on the east coast of the United States are the same because of the radius of the Earth that defines the ocean between us.
There you go. There's a big claim. Mean sea levels are the same. Unless he means they're zero. They're their own zero. So whenever you do it, you reference a zero. He may think they're all the same.
He said that they measured it by means of radius.
Yeah.
Somehow.
Yeah, they watch the tide go up and down. And then they measure that to the center.
They get the rope. Yeah, they get the rope. They give nut on the rope. They put it away on the bottom and on the end of it. They put it deep in the ocean. You'll see how many nuts it has to reach the radius.
It's mad. It's mad how he can think this. He's got to be right. I was always thinking, Larry Scott. He's obviously could be a sophist, right? But if he's a sophist, he's doing this. He's got to be fooling the Globers with it, because he's not fooling us. He's saying such stupid stuff, and it's all obvious that the model's dictating this because it's so far away from reality. It can only be a model dictate sort of stuff. So he's got to be fooling the Globers. Larry Scott must think that the Globers are stupid because they have to take this on. They're forced into it. At the same elevation, you think?
Yeah, the same elevation, zero mean sea level. Yeah.
Okay.
Zero is level, definitely. Yeah, I'll go with that.
I get it. So when they all get their own mean sea level, right? They're all say, because they can't all be the same, right? No, they're not all 0 to 0, are they? The mean sea levels. They are different, aren't they, for different areas? There's no way to actually reference them to each other because they're all their own mean sea levels. I mean, you must have heard the problems they had in the UK when they first started trying to work out the mean sea levels.
Yeah, and those differences are relatively small. They're only in the couple of feet range.
What do you mean? The differences with elevation, right? Bear in mind, Larry Scott has just said he did a massive survey for flood purposes, right? To show everyone where the floods are. And now he's saying just a couple of feet. I would imagine that a couple of feet would matter quite a lot if you're on a floodplain.
Of course.
How can he say that's a little bit?
That's a massive discrepancy.
Yeah.
That's not acceptable in surveying.
Larry, shame on you. They're relatively like having a difference of mean sea levels of a couple of feet is a bit of a problem, Larry.
Yeah, that's why they addressed it. But the couple of feet
They didn't. They just went to 1.
Yeah, because of the distributions of gravity and tides and all that.
No. Just because of the discrepancies between the other ones. It was just easier to take it from 1, which is what they do now, right?
Okay, take that singular point that UK uses,
Newlyn.
and from that point, measure the elevation against mean sea level of New York relative to that single point in UK.
They're on their own reference, Larry.
I know, but I said compare the two references, and you'll find it's only a couple feet different because of the
How
irregular.
do you compare them?
By measurement.
How?
But since because of 3,000 miles of ocean, yeah, that does get pretty fucking hard. But we have the shape of the Earth as measured, so yeah, that's not hard when we measure the radius of the Earth first.
That one I'm interested in, by the way.
Yeah. He's admitting he cannot measure between coast to coast in the ocean, but we can measure the whole radius.
And he measured the radius. He measured every distance to the sun. What else?
Yeah.
Distance to the sun, to the moon. He measured everything.
It's mad, isn't it? That
It's mental.
he just had that mental breakdown. Then he realised that he couldn't back up what he just said. That there was nothing there when he went looking. There's nothing in his bag of tricks that could help him out there. Shocking.
We just call it sea level. That's it. There's
You've got to
nothing else
measure the
into
radius
it.
of the Earth. That's not hard. That's been done hundreds
How
of
do
years.
you do that?
Yeah, I'm not too sure about that one, Larry.
I do it in ways that you don't believe,
Go on,
so there's no point
tell
in
us one.
discussion.
Tell us your best one.
Yeah, I've been using these tools for, 25 years, and I've never accounted for any of that. So you go ahead, mate.
Have you ever measured more than a few hundred feet in any direction? Did you do 10-mile observations?
No.
Yeah,
Okay,
you have.
then
He has observed things at 10 miles. Spot on.
Oh, sorry. Yeah. No. I thought you meant using the tools.
Well, you have. You've looked through your auto level and seen 10 miles things 10 miles in the distance, right?
Yeah, but not at work.
Well, yeah, you're not actually doing anything, but I mean, the observation has been made.
Oh, we've done it. Yeah.
Yeah.
There's definitely some sort of optical drop there. Yeah.
Mm.
Or whatever you call it. It's below the crosshair of the horizontal.
I'm sorry again, Larry. You said measuring the radius of the Earth. Now, how do you do that? Can you tell me? I'm a very fucking outsider in this kind of question, you know. And I would like to know. I'm very curious.
By measuring the angle to stars from vertical at distances significantly separated, like 250 and 500 miles.
That sounds fantastic.
You mean a sextant? Using a sextant or what?
No, the theodolite I showed you. I put my instrument on the screen.
You use a what for measuring?
Theodolite.
Stars. Theodolite.
A wild T2, is it, Larry? Model.
T2, correct, and T3 on occasion. Depends on what I'm doing.
Pretty old school.
Very old school. Because old school still works.
Yeah, I love the old school stuff.
Definitely right angle triangles. Yeah. Horizontals. Yeah. Triangles.
Yeah. That's the point. He's using an old theodolite that measures angles between points, i.e. straight lines.
That was another concession.
Yeah. Yeah. Just triangles, right? Straight line, old school, measuring.
Yeah.
Like they did in the old days, before GPS was even invented. Before they even knew about GPS. Just traditional angles.
It was called just GP without the S in it.
Yeah.
Without the system.
Theodolite for angle.
Okay, that's the instrument I use when observing the sun. Yes. And it measures to a microradian. Yes. Not looks like, not a sextant, not a rule of thumb.
Why are you looking at the sun with that for, by the way?
To measure the radius of the Earth. You got to keep up.
Sorry, no, I'm literally just, I'm in construction.
I'll point that out again. He's looking. Please do not look at the sun through optical magnification instruments. It's not a wise decision. I don't advise it. Don't ever look at the sun through a telescope, binoculars, anything like that. Observe it indirectly. So I don't advocate looking at the sun, but definitely I've never been shown yet the link geometrically to looking at a light in the sky and measuring a radius. That seems fantastic to me.
Going to measure a radius of a circle around that light in the sky.
He's going to talk about the radius of the Earth that he thinks he's doing. He's going to look at the light in the sky to measure the thing he's on. That's why this is another big X on Larry Scott's surveying credentials. Ridiculous, Larry. Doesn't make any sense, but
imagine if you have to do 3 different readings to 3 different celestial bodies. Then you have 3 different circles of equal altitude. Then you have a big problem because you're going to need 3 spheres with 3 different radiuses.
Well, he's just talking about doing it with the sun, as I don't think we have got more than 3. But I mean, I don't know whether he would be able to adjust this to other lights in the sky. And I don't even know the process of how they do it. You know, how they get the radius of one from I haven't got a clue. Literally, it doesn't make any sense why he's even said that himself. I don't think he realizes how he's done it.
And you know, I'm just
Yeah,
asking
and it-
questions because there's questions I've got. I've not done
Okay,
observations like you have before.
Okay. Let me roll that back a little. I apologize. Yes.
Yeah,
Construction grade equipment is not as high an instrument as that. Normally, correct. That is a very high level instrument, and in construction you use a lower grade of instrument because it satisfies the requirement.
So there's no like are they rectilinear, those lenses and what have you? They're like, you know, there's going to be no, you know, like you're going to see. I don't know what the word is. You know what I mean? Is there going to be curvature added by the lens or anything like that?
It's the highest grade of optical tooling, and that's why instruments have a crosshair, so you're measuring through a specific point through the optical path. And as you move the instrument, the crosshairs, you're measuring the angle from where the crosshair was on the target, an angle to where the crosshair is on the target. So the lens has nothing to do any curvature or radial distortion of the lens, which at that focal length and for that tiny field of view is very, very, very small. But we're not measuring across the field of view. We're only measuring at the incident of the crosshair.
Like what Larry's saying there is the theodolite just measures from point to point. It's the angular difference between the two. Inclination of one straight line to another. And that's all he's talking about. He doesn't seem to be horizontal or anything. He's just going from a point to a point. Theodolites measure angles.
Yeah. Hey man, thank you for your hospitality. It's getting late for me. Have a good night, everyone.
Okay.
It was lots of fun. Cheers.
See you later. Is it that late? It's not that late. Got a couple more to go through. Did you get that, guys? Did you get what you want?
Yeah, sorry. Yeah. No, I'm doing something at the same time, so I'm just sorry. Yeah, but thanks for that, mate. Yeah, I've just So how far do they say that? Yeah, these things are capable. Are you saying that you can look 10 miles with this thing and it be?
It's looking at the sun.
That's 93 million miles away, isn't it? So they say.
Yeah.
Wait, sorry. He's looking at the sun
to get the radius of the Earth with a really old.
Looks like something from the in the military or something.
Yeah, I've seen that. Have you got some scratches on the lens there, Larry?
No.
Somebody been turning the cap with a stone in it or something, and
no. Where do you see scratches?
It's got like circular marks on it.
Oh, the circular marks? I mean,
Yeah,
the precision reticule that is the same diameter as the sun? Yeah.
What, the same diameter as the sun?
Same diameter as the sun.
Circular reticule, the circle in the reticule
Yeah.
is 32 arc minutes in diameter, as is the sun, and that is used to align.
What focus have you got? What magnification have you got on that scope?
24x, and it's only got a 1 degree field of view.
A 24 times scope, and you're getting the sun. That big.
And or Polaris, or a strobe light on a radio tower 25 miles away. Yeah, I can do that. Isn't that amazing?
24 times scope's not that good, though, really, Larry.
Couldn't you get that more like in the middle? That last bit?
Yes, I could. But when I was holding the camera, yeah, I couldn't do both.
Oh no, that's fair enough. No, I just didn't know if there was a reason. That was all. No, okay, yeah, it's a bit awkward, like.
Yeah,
I'm sorry, I really don't get this. Shouldn't the crosshairs be in the very middle of the frame?
Yeah.
But is it?
Yeah, the crosshairs at the very center is for measuring angles across precision targets. And
Can you see what he's saying? Shouldn't the crosshairs be in the middle of the picture? Not off to one side. There's just so much wrong with it. He's not put it where it should be. You know, like there's not much right about this picture. At all. Just that crosshair is not in the center. These bits aren't around where they should be. You'd at least have took a proper picture when you were doing
and
it.
the sun is so fucking big that, yeah, it's hard to, you can't pick out the center precisely. So you use the circular reticule and get concentric with the sun. And that's,
Larry,
and that's the same.
I think
that's the same.
he means shouldn't the crosshairs be in the middle of the picture? I'm asking a similar question.
The picture or the frame?
Yeah.
We just talked about that. I was holding a camera and I was taking a picture. I could not do both because the sun moves so
But
fast.
then, sorry, then that's not the sun. That's not the whole sun. That's something else then.
No, that's the whole sun.
It cannot be.
Do you? How do you know that when you're it is vertical, it's vertical, and when it's horizontal, it's horizontal? How do you know that that's right? Because you get how accurate it is. I bet it's really accurate, right? An arc minute or something like that. So that's the end of that one. Well, it's not the end of it, but that's he does go into triangles with more than 180 degrees. But that's just another concession of ridiculousness. Globe model. This is a video. This is another one. I think this one's got blue in it again as well. This one's called "Is Larry Scott a Real Surveyor?" Question mark. Listen to the beginning of this one.
Can you establish that horizontal plane in 1 mile?
I do not know the method that satisfies what you just described.
Like,
It's
just
hard.
create that horizontal plane in free space. There's no way to do that, to your knowledge?
I don't know of a method off the top of my head. Maybe I'll think about it a whole lot.
Appreciate it. Thanks.
But when I'm using my equipment,
3 coplanar points, and bam, there's the radius of the Earth.
Got here. Oh, no,
Right.
not that.
I'll nip up if you.
Is there a way to create
There you go.
a horizontal plane using a theodolite or an auto level and not looking in one shot?
I'd have to think about that real hard. Like I said, if you set up your instrument 15 feet above the water and go out there a mile.
Okay, so I guess we're looking good. We got audio. We got everything set up. Hello, Marcus Dresden, Zep Tepi, Village CDF controller. Marcus Dresden, Village, Zep. When I come back, I'll scroll up. I'll verify
He had
that
to
I
think
didn't
real
miss
hard
anything,
about that.
any
Right,
support
did
to the
you
channel. So if you got
hear
a cover
that?
too,
You got it right.
throw it this way. Let's do
fucking
this.
ridiculous.
Yeah, I have to
Jack
think
will
real.
pull
It's
up,
not finished.
see
He comes
15
back.
till it
Here
hits
we
the
go.
crosshair and see if it's 15 feet above the water. Then on the intermediate poles, you jack them up until they hit the crosshair, and you'll see the tops of those poles all line up, and you'll see a different distance to the water on every one of them. And that is how you're measuring the curve of the water relative to an auto level.
Right. So
And with
he's
an auto
got
level
15.
at a mile, you're going to be a little bit in trouble because you can't.
Volume. Fuck. yeah,
Wait,
yeah,
hours after
yeah.
show.
Let me wait for all the muted and sound.
Right, so this is this is Rakir asking Larry Scott on how to coming up with a method. I'm guessing it sticks in water always.
Come through.
Here we go.
Shame on me. See that? My forehead see through. Now you see it. Woo! Hey,
Right.
I'm not gonna be able to see. There are two chats, but it will get fixed. It will fix itself. So let's see what we got here. Oh, no, not that.
Excited. Is there a way to create
go.
a horizontal plane using a theodolite or an auto level and not looking in one shot?
Right? He's asking Rakia. I don't know, is Rakia in here or not? Maybe not. It'd be good if he was in here. But yeah, he asks, is there a way to establish a horizontal using a theodolite or an auto level without looking at it in one shot over a mile, right? And then Larry.
I'd have to think about that real hard. Like I said, if you set up your instrument 15 feet above the water and go out there a mile.
Okay, so.
Right, so if you set your instrument up 15 feet above the water and go out there about a mile, and then he does a load of talking, right?
You know what he should have said? Land surveyors survey water. We don't do that.
Yeah,
Don't look out that.
I'm sure he said
That's not
that
a
before.
technique.
I'm sure he heard him say that. They
No, you had
don't
to think
survey
about it
over
real
water.
hard.
Yeah, he has said that they don't survey over water, but that, if you listen to it, right, you set a pole up at 15 feet above the water, and then you go out a mile. Right, here we go. A pole up.
A pole up to be 15 till it hits the crosshair and see if it's 15 feet above the water. Then on the intermediate poles, you jack them up until they hit the crosshair, and you'll see the tops of those poles all line up, and you'll see a different distance to the water on every one of them.
Right, now, I don't know. It seems like he's suggesting that you lift the poles to the crosshair and then measure down on the pole. I mean,
Yeah, if he's not doing reciprocal leveling or differential leveling, I would love to know what technique he's using as a professional surveyor to do that.
exactly, right? He's not a differential leveling. You would put your thing there and you would measure the distance, right? You wouldn't put 15 feet or 15 whatever at the crosshair and then measure down to see how far away that is from the... That's ridiculous. I can't even
Maybe he's
imagine
joking.
what he's talking about. It's
He's
mad.
probably just joking around.
Well, yeah. I don't think he can't be a real surveyor, right? So,
And that is how you're measuring the curve of the water relative to an auto level. And with an auto level at a mile, you're going to be a little bit in trouble because you can't flip the auto level over. So you'd have to have a more sophisticated.
right. You'd be in trouble over a mile because you can't flip the auto level.
Why in the hell would you want to flip that?
You- Yeah. You can't flip an auto level, says a supposed surveyor. Why you'd be in trouble for overdoing a measurement over a mile. Doesn't make any sense. Another big X there for Larry Scott. Pointing out that you can't flip an auto level. But that flipping may come in a bit. Larry, you can't. It wouldn't be able to float, would it? Like, I can't imagine what he thinks. I think what he might think. Remember,
Oh, he probably thinks it's like his little
Yeah.
telescope deal.
Remember when we were watching that other video of that guy that couldn't set his tools up, and there was
Oh yeah,
one
I
of them.
remember
There
that.
was it was
Yeah.
upside down.
Mhm.
Remember that one of the
Haven't seen that
pictures
guy
was
in a while.
upside down. Well, I think
Yeah.
he might be thinking like that, right? That people make mistakes about putting the thing the right way up, and you can't flip it, which is a theodolite sort of thing. I don't know why you'd want to do that anyway, to check it. But yeah, he might be. But I mean, he might not. He might have some sophisticated auto levels that.
Well, I like to say.
I've seen a couple other guys.
Level with
Have you? Go on.
I've never flipped an auto level.
No, that's why he said you'd be in trouble because you can't. You can't. You'd probably break it, wouldn't you?
Do you have to flip them to measure Earth curve or something?
No,
'Cause
no.
Maybe I'm doing it wrong.
He's getting mixed up with his theodolite.
Maybe so.
Yeah.
He might have just made a small mistake.
Calibration check with a theodolite.
I heard you flip him and you give him a good couple of kicks and then you measure them.
Bang him on the ground a little bit, make sure everything's working good.
Flip him. Shout at him a bit.
Flip an auto level. I guess you could, right? Like, you know, put it on the transit, set it up, use the bubble level to make sure it's horizontal, adjust it, and then flip it over. Wait, no, it would be on the ground then. The legs would be sticking up in the air.
You'd have to do a 2-peg test again just to make sure you haven't knackered it.
He might have made a mistake. We'll give him a break.
Yeah.
I mean, he does think concrete follows the curvature of the earth. So.
Yeah, well, I think we get to that. I think it's on this one because this is you talking to him, so I'm pretty sure you
Yeah, I've seen a
say
couple other
something.
guys doing that kind of crap, but they're not around anymore.
Yeah.
You know.
Yeah, there's nobody to really explain any of this because obviously Larry isn't capable of explaining this. As you'll hear, listen to this, right?
They left it
We'll
to
offer some
B-ball
help in a bit.
and blue.
That's all they've got left now, isn't it?
You know, that becomes very, very expensive. And yeah, you were 15 feet above the water and you set a bunch of stakes all lining up to the crosshair at a mile out, you'll find that that's more than 15 feet above the water. And you'll find the intermediates, if they all hit the crosshair, will be slightly less and slightly less and slightly less until you get back to the instrument where it's 15.0.
Okay, I'll ask my question again.
Do you like that? I mean, Dave's about to ask him his question again. But he said that would be more than 15. That was sort of suggesting that the water level is dropping away from the horizontal, right?
I think his suggestion is perspective.
Another one. I mean, I know another guy that said that, and he had to go away. Do you reckon a Larry being able to do that? Because that's him. He's definitely said it. And now Raki is about to ask him again the same question.
Again, with the most expensive equipment available, can you create a horizontal plane 15 foot above any surface and then and without shooting a mile if you want to measure a mile? Is there any equipment available where you can do it in shorter segments and still create a horizontal plane in free space? Is that possible?
What's your budget?
Free space.
Yeah.
He
The
said
answer to
it.
that
Cool.
is no. If you're going to be measuring little short chords, then you will be tracing.
That's not what I asked.
That's
Can I create a horizontal plane for 1 mile using any type of instrument, but not shooting in one shot, 1 mile by moving that instrument? Can you set it up to where it's not doing anything but create a horizontal plane? No matter how many times you move it, no matter if you set it up one day and come back a year from now, can you establish that horizontal plane in 1 mile?
I do not know the method that satisfies what you just described. No,
What
I
the
don't.
fuck?
Thank you.
He doesn't know how to do differential leveling?
He doesn't know how
Across the
to
lane?
sort of think, right? And notice
They-
Dave said he's very, very, very good with this, right? 15 feet above for a mile. And Larry says loads of short chords, to which Rakia shouts him down and says no. Like, because you can't have a chord 15 feet above. So you're only going a mile. Like, where are you going to get a chord from? So he was right to say no. But yeah, dead right. This is me now, not then.
Trying to get away from the chord and the refractive effects. So, 15, 20 feet seems to be that magical number for the mile or 2 miles. But they just want that one shot. So I don't.
Well, you can't
They
have
like-
a chord that's 15 feet above the surface, can you? I mean, that's
No.
taking, like, trying to find some sort of a circle or something and imagine it. It's nearly as bad as Blue having an internal tangent plane. He's having an external chord.
As soon as you put that Sagitta, like Lake Pontchartrain at 12 miles, 90 feet above each shoreline, then that means the tangent line is 90 feet above each shoreline.
Yeah.
That's trouble. Even Left Lane went today. Today when I explained that, Left Lane goes, "Well, that doesn't sound right." And I'm like, "Yeah, you think?"
It's the unclamped. That's what happens when you unclamp the tangent plane, isn't it?
He just got unclamped.
Unclamp that hump.
I'm going to get to the one because Larry to say no, he can't even think of a method that satisfies it. A horizontal over a mile.
Man, that's crazy. Anyone, the Illinois Surveyor can show you how to differential level.
For a mile? Yeah.
Yeah.
Yeah. Yeah. But hey, this is Larry, right? Larry Scott. Larry GPS, he's the top man at Jose's at the minute.
So Illinois Surveyor knows how to do it, but Larry GPS doesn't.
Yeah, can't even contemplate of the method. I do not know the method that satisfies what you just described. And I thought it was quite simply described that really well, but I mean, listen to what he says. So that's another big red X on the mark of Larry Scott Surveyor. Doesn't think you can establish a horizontal plane over a mile. It doesn't think surveyors are capable of doing it. Doesn't know the method. It keeps going for a bit. He says, "Thank you."
Because if you're going to look at a horizontal plane, you have to look across the entire mile all at once.
Would you agree if we did that on one day it would be one measurement, on the next day it'd be another, and a year from now it'd be another?
To slight variations, but if you monitor the barometric pressure and temperature, if you go out in similar conditions, the optics will return the same.
fraud.
Got to go out in similar conditions.
Yeah, because you have to
I'm
chase
calling
the atmosphere
fraud.
around.
Yeah,
You
yeah.
can't control the atmosphere. You just
Well,
go
he's
out on
not a
days where
surveyor.
it's consistent.
Absolutely, he's
Hey,
not a
Larry,
surveyor.
could those
He's not even
differences?
He's not even convincing as a fake surveyor, right?
He's a terrible actor.
He likes
Terrible.
to think he's a surveyor, and unfortunately, He's been over at Jose JG's pretending to be a surveyor, and there's a lot of people over there. I'd have to call them gullible.
I need to see if Travis will put that video out where Larry Scott came over there and talked to me and Travis one day, and he was a hobbyist and he had bought some old Theodolite and he was looking 24 miles across to a mountaintop. The guy was absolutely clueless. I didn't pay much attention to him, but 2 weeks after that, he was a big shot in this arena.
Yeah, same as Jesse. That Jesse, that Jesse, not that Jesse or whatever. I don't know. Not you, Jesse. Whatever he's called. That's another guy who's done a very similar thing. He's bought some old stuff, restored it, gone for a hike up to the top of a mountain, and decided to use it as a camera or something. I don't know.
In a personal capacity.
Yeah.
That's strange, right? Because Logos is going to give us another one. I don't want to be keeping going too late. I wanted to get to one more bit with Larry and then show you this bit with the guy we were just talking about. There is called From Jesse, and he's been sanctioned by Jesse Kozlowski. He's just done some videos just recently. I'll go for this a little bit longer.
Yeah, that's fantastic. Anyone that's willing to do that. And carry on. Right, here we go.
Be predicted.
Oh yeah.
Is that one of the reasons we usually don't like to shoot over a mile because of those conditions? We usually like to do maybe 300 or 400 foot to be more accurate.
Yeah, it's because of instrument error and atmospheric stuff. Yeah, you keep it down to short chords so that you are running parallel to the surface of the Earth, to where the curvature of the Earth never gets really, hardly, but an eighth of an inch or less, and then you can ignore it. And as you keep moving, then you're tracing the arc.
But there's no way to do it in those short sections.
You get that right?
That sounds like the main surveyor. He said differential leveling techniques done correctly.
Yeah, he says
here.
something like that in a bit again. He does say that. Just like you create that horizontal plane. Oh no, that's Rakia, isn't it? Yeah, to where the curvature of the Earth never gets really, hardly, but an eighth of an inch. An eighth of an inch is about 3 mil-ish, something like that, yeah? About 200 meters? About an eighth of an inch on their model. That's for the Ruhif numbers.
It doesn't really matter because they don't ever measure curvature. They just calculate.
Yeah.
Segments and discord what's underneath you. Like, just create that horizontal plane in free space. There's no way to do that, to your knowledge.
Shout out to Brian Lee.
I don't know of a method off the top of my head. Maybe I'll think about it a whole lot.
Right, I'll go back and do that.
He's gonna think about it a whole lot.
Yeah,
He's
a
probably
lot.
gonna
There's
meditate
lots
for
of people
3 hours.
like really big thinking.
Mm-hmm.
Right, so here we go. This is what Rakia says. This is from tracing the arc. The bullshit comes out of Larry.
Yeah, then you're tracing the arc.
But there's no way to do it in those short segments and discord what's underneath you. Like, just create that horizontal plane in free space. There's no way to do that, to your knowledge.
I don't know of a method off the top of my head. Maybe I'll think about it a whole lot.
Appreciate it. Thanks.
But
he doesn't know of a method to establish a horizontal plane. The guy's not a surveyor. Sorry.
when I'm using my equipment.
Right, so he's obviously never heard of differential leveling, has he?
I want to send that to the Illinois surveyor.
Yeah. Yeah.
Wonder what he would say.
Yeah.
But then he'd get called a flat earther or something, wouldn't he? You know what Larry's like.
From
Yeah, I don't know. I don't know the Illinois Surveyor, but
No.
you know.
I know, but you'd be opening him up into this world. But I mean, I've been saying that for ages, right? These aren't real surveyors. Come over and prove us wrong, Larry, if you want. Like,
Oh yeah.
yeah,
This is the right of reply show.
Yeah.
Right of reply.
yeah, right.
You have the right to come and speak. You have a right to make a response video. Whatever you want to do.
Yep, you're the right to go on Jose's and talk about this if you want. But I'd like to, offer anybody up if anybody knows what Larry's talking about. Anybody wants to tell us what's going on. We go. So he's now explaining. Right, Rakir says appreciate it, and then Larry explains about what he does now.
Appreciate it. Thanks.
But when I'm using my equipment from 1 mile to 25 miles, I get very consistent results over a multi-year project. So,
Yeah, I got you.
and that's as many miles measuring vertical angles that are, no more than 1.5 or 2 degrees. Quite often only half a degree. And I get,
Whoa.
down to a couple arc seconds over
Ah.
100,000 feet. And
Over
that's
100,000 feet.
not a lot of
Over
difference
100,000.
in elevation. So I measure, I not looking over water. I'm
What a train
using
wreck.
ridges and valleys to where the air column is is very consistent.
Using
go out
ridges
over,
and
like,
valleys.
the multi-years,
The air column.
and if the temperature is
The air
always above
column is
50 and
not-
less than 90,
Multi-years.
and the altimeter is
Imagine
only like
the-
about a quarter inch
Yeah.
left or right,
Imagine the air trying to establish an equilibrium between a valley where a river's flowing and a mountaintop where it's cold.
On the ridge, yeah.
I mean, you'd have this constant flow of turbulence, right? Heat, rising, cold, dropping, moisture.
Yeah, but
No.
can I ask, because I mean, this is just one of the things that comes to my mind. What job's he doing?
Nothing. Not a damn thing.
What the purpose of this? Because he says he does it over a multi-year thing. Right, I've noticed George does the same as well. He's doing a thing. I mean, what is it that he's doing?
Globe defending. It pays pretty good. I guess.
Crazy, right? But right, he says, and I go out over like some multi-years. And if the temperature is always above 50 and less than 90, and the altimeter is only like about a quarter of an inch left or right, what's that?
He's saying he's off of his equilibrium. He's above sea level at the balance.
Yeah, but what's the altimeter, left or right? I mean, that would be a tilt to the left.
It'd be positive.
Or a
No, it'd
tilt
be
to the
positive
right.
or negative. Yeah. You'd have plus whatever, standard atmospheric pressure, whatever you want to call it.
No, it's an altimeter.
Or less. Same thing. As a barometer.
No, it's an altimeter for knowing how high he is, for the altitude. Altimeter?
But it's based on the pressure.
No, he was talking about barometers, and then he went to the
Oh, yeah.
altimeter. Two different tills, right?
Yeah, I mean, truly, though, like you said, you could say it's just, your vertical altitude.
Yeah, so I'll let you listen to this. It is quite good. I mean, this is.
and I go out over, like I said, multi-years, and if the temperature is always above 50 and less than 90, and the altimeter is only like about a quarter inch left or right, I get the same results, and I go through the math. And see, there's your problem. I go through the math, and I get very consistent results. If you ignore the math
What's the
or
scale?
try to just use some sort of visual interpretation
ignore the math.
with an instrument that's not putting out degrees and not dealing with distances and not dealing with angles and trig functions, then I don't know what the hell you're going to get or how you're going to perceive anything, and I don't know then how you have footing to say that the math is all made up or fake.
Yeah, I don't say that. So
Right. He says, and I go through the math and see there's your problem. I go through the math and get very consistent results. If you ignore the math or try to use some sort of visual interpretation with an instrument that's not putting out degrees on and not dealing with distances and not
Then he
dealing
just
with
doesn't know.
angles and trig
He just doesn't
functions, then I don't know.
That's it. He does not understand any of those things he listed.
Well, no. I think what he's done there is he's talking about the functions of he's disregarding an auto level completely within all of that. Thanks, Matt.
That's what he just said.
No, he said if you're not dealing with it, right? So the one of
You're going to perceive a number on a rod.
So you know this. I think that one. It's just a quick one to get over that. Pretty sure this one. There was one.
Straight line tangent at the intersection.
He did force the line, didn't he?
The only thing that's going to end this is a force the line test.
Keep on divided well.
Level. The old one with the old Brian Mullen force the line, because I've never really looked over that either.
Oh, Brian Mullins?
I think it's linked. He did force the line, didn't he?
The only thing that's going to end this is a force the line test.
Yeah, he proposed it. I thought I saw something like a year ago where he wanted to build some big steel rail contraption, but I don't know. We've got the Lygos vacuum tubes. That's a pretty good construction of a straight line tangent at the intersection and climbing about 1 meter and something in elevation to maintain straight. So there's that.
Hear that? Tangent at the intersection point. Nice claim there, Larry. Thank you very much.
I think we lost him. Right there.
Larry?
Mm-hmm.
Oh, is he gone?
He leave
Yeah.
without saying bye?
He may have dropped out. Maybe he'll come back.
Yeah. Yeah, I wanted to have a word with him about our water level test, the straight line test.
Mm-hmm.
Got into that. But yeah, I was good of him coming round.
Yeah, great. That was I don't know how long that was. Maybe an hour? Not really.
I wanted to know if he had gone back to his building.
Here we go. Yeah, I wanted to get there's loads of questions about Larry.
Well, he's
Crap,
supposed
he may
to,
have.
you know, when it warms up, he was supposed to go back and shoot it again. And I want him to go in the middle and shoot either way, you know.
He may.
Right now, this, I think we've decided we're going to be going over this video. Rikier paid 400 quid or £800 or $100 or whatever to Jose for this particular video of Larry Scott claiming to have measured 2-inch drop down the side of that building. Earth curve down there somewhere.
They wouldn't give the video for free. They made me pay for it.
Yeah.
They know.
He was hiding it away, wasn't he? He made you pay for it. But so we will be going over that this week.
Larry.
Wednesday.
Yeah. Wednesday, Trivium Day. Tomorrow we're going to be doing Logic night, and then we're going over this particular thing because this is Surveyor Week. Anyone who's claimed to have been a surveyor will go over anything that they've claimed and just try and judge the validity of it all for the whole week. See how many surveyors are left standing at the end. But yeah, this is the subject. It's been going on for over a year, this one. Yeah, this one's comments from a year ago. So this is coming from Rakia's conversation that he heard Larry Scott say one day on Jose's chat.
May have left because he could sense that was coming. I don't know.
Yeah, I don't know. I hate to put that in him, but he usually doesn't leave. But usually people say, bye when they're leaving. So maybe he just dropped out. Maybe he's not being, a jerk.
No,
he
he's
just
fine.
got disconnected.
Nah,
Yeah.
he just got disconnected.
Yeah. No, I
Cool.
think he'll have lost his signal or something. The power will have gone around at his house. He wouldn't have just dropped out like that.
You still there, Beth?
Yeah, yeah.
Oh.
Yeah. Are we on?
Yeah.
Mm-hmm. Wait. So, if we get this, the test. I mean, what's your idea of what they were doing with the force line? What was that about? I never understood what they were doing. They were just building a structure level, were they? Is that what forced the line?
Well, what Brian Moans described, I don't know. I hadn't seen that since well over a year ago or something, and he had brainstormed something where they could build with at no minor expense, with I-beams and stuff, try to build something of significant length, like a mile or something, and go and in his structure, he wanted to, build something at constant elevation and something that was tangent to see if you could or if it would be evident. And
he wanted to build something that was tangent as well as level. I mean, what's that? Tangent to...
Because, in his structure, he described building both because they're not the same.
So he's building two structures in the force line.
Well, I don't recall the details of that much because Brian Mullins was being, his typical crazy. So, he was describing something that was overtly expensive, unnecessary. And he was going to, put a line of steel columns and then across the steel columns, lay I-beams, going out horizontal and going out level. So he said, well, if you could do both, let's just build it and see if you can do both, and then survey them up and measure them and check them all out. And it was ridiculously expensive. And so what?
So they had I think I heard when they were saying something about it the other day, either 16 or 160. I don't know, 1,600. It's 1,600 meters for a mile, isn't it?
Something like that.
And have you ever seen Slice Barkane's bending water level experiment? Because that was 16 meant to be when he does it, not the leaky one, the new one. That's meant to be 16 100 meter water levels. Would they be like your verticals? Or would you class that as being the level or the horizontal?
that Sly Sparkane was doing?
I don't know what the exact details of his quote new test, where he's going to set the vertical water columns on top of the levee. I mean,
Yeah, he's just doing 16 individual 100 meters and putting them, where the water levels of at one ends. He's matching the water level of the start of the next 100 meter, and then he's going with that, right? He's marrying up 16 100 meter water levels.
Yeah, because when he did that first time, he just made such a rookie blunder, as he didn't check the elevation on his first sight, and it climbed up several feet, and he didn't realize that until he got out there with his water levels and found, oh my God, the far end is higher than I thought, because he didn't do a proper survey.
That's right. That's Larry Scott spilling the beans on Sly Sparkane's bending water level test, the first one. He couldn't get water to go upwards because he hadn't worked out the elevations of the land that he was working on in order to do his test. Shocking, I know. But Larry gave us that. Larry Scott gave us Sly Sparkane not being able to set up his test. That's why it failed. But he's going to do it again soon.
I know. And he was counseled to say, you get out there and survey it up. And he goes, oh, it looks level. Well, it wasn't, because the water level proved it wasn't. It just looked level.
Right. Oh, well, I heard that it was just leaking all over the place, and he couldn't find leaks. Is that what he said? He didn't say he had a problem elevation.
He had both problems. It was leaky.
I think that was one of the resulting leaks that we had found when we walked the entire line trying to find out why filling up post zero kept on going down. And we wanted to find out why that was, and this seems to have been one of those. But we had actually, I had actually taped that all up, and that tape is outstanding, by the way. So now you're going to see this one. And put it down at level. Now this one is back at 11. Now remember, post 1 was 11.5. Post 2 for some reason was 8.5. Okay, but this one's back at 11.
But he also ran into where at the far end it was too high. He had both trouble.
It was too high.
The far end, yes, appeared to be too high, and it was leaky. He had trouble, and I think he should have put a little more effort into the site selection and surveyed it up proper.
The water level was too high, or the land was too high.
The land was too high at the far end. It climbed up. The land was climbing up a small amount, which he didn't perceive by a visual inspection, and would have learned if he'd done a proper inspection.
He's got an auto level this time, though, hasn't he? He'll be right. I don't know whether he got measuring staff. Do you know if he got a measuring staff with it? Or he just got the auto level?
I don't know what he has. I only catch him a couple of times he puts out a video. I'm not tracking his
See, there's another big X against Larry Scott. He's got an auto level Sly Sparkane, and he doesn't know whether he's got a measuring rod to go with it or not. Another X there for you, Larry.
His experiment outline, or his I got an idea of he was going to go up to the top of the levee, because that is a constant elevation, unlike where he was on the bike trail.
Yeah, that sort of makes sense, doing it at the towpath at the side of the canal. That makes sense. But I mean, what I was trying to get at is
that 100-meter individual things, would that not be like a force in the line sort of thing? Is that not what Fly Spark Haynes is doing?
No, because anytime I hear the term force the line, it has so many convoluted approaches to what the force the line is even trying to be, or what it means, or how they're doing it.
Okay. Well, Sly Sparkane called it his a bending water level experiment. Do you think that's what would happen? Would it show a bend?
Well, it would show the constant elevation, and the fact that the constant elevation and a tangent from one end are different. Yeah.
Tangent. It's an even elevation, an even altitude. Sorry, can't get them mixed up, can we?
Constant elevation. A constant elevation. Yeah.
Yeah, an even altitude though with the water level, because it's not. It's above the ground, isn't it? That's an even altitude rather than an even elevation. If you're using a water level, the tool.
Okay, the elevation of the tops of the water columns.
That would be altitude, wouldn't it?
Okay. Yeah, 3 feet of altitude above the levee. I didn't look.
Couldn't be a tangent, could it, Larry? If it's at an altitude above, it can't be a tangent then, surely. Geometric.
I said from one end, you would have the tangent, and you would have the constant elevation.
Altitude, though. Yeah, if it's an altitude, how is it a tangent? Tangent needs to be touching something, and if it's at an altitude, what's it touching? It's just in the air. You can't have a tangent touching air, can you? I mean, that's ridiculous. That's presupposing air curves. You don't do that, do you?
Well, I mean, if you're going to make a silly description like that, sure, why not?
What you think?
Because if you set up a water level, and then you set up an auto level, and the water level as it progresses out a mile will be at the constant elevation, and the auto level at one end will be looking out tangent, and you see the two will be separating as distance goes by. Just like on the LIGO vacuum tube.
Water level drops. See, there you go again. Separation between horizontal and level. One of them being a water level and the other one being the tool, auto level. They claim there is a difference between an auto level and a water level. Very easy to check. I don't know why they're saying it, really, because it's one of the easiest things to check. Right, so the separation of the water level from the auto level is that the water level goes down, separates away. Now that's what we've been dealing with. I might have to change this in Discord. Now this one is from a guy who we were talking about just earlier. It's called From Jesse. This guy's sanctioned by Jesse Kozlowski. And it's at the end of the show. I don't want to give him... I think I'm giving him any heat or anything. But this is a video from Jesse. It says... Today the air was calm and warm and the water was cold. I measured the angle to the horizon from 4 different heights. Approximately 2 feet, 5 feet and 15 feet and finally 55 feet. I don't know how he measured these, or approximately. So he didn't actually measure the heights of the places where he was doing the measurements from. Just accent. So it says for the first three locations, the water horizon actually appears above eye level. Above eye level. But the higher I got, the lower it got. Strange. At 55 feet, it was below eye level. Notice that the very indistinct horizon we are seeing much farther than ordinary. Genius. At one point I said something was 2 degrees. I meant 2 minutes. Sorry, it was unscripted, unrehearsed, and a single take. You get real life that way. Wow. He does it live. It's good. Right, so check this out. This is some good stuff.
All right, I'm out here. I think it's called the Dungeness Landing in Sequim, Washington. I'm down on a low tide.
In Washington, Dungeness Landing.
Above the water. The tide's coming in, so I haven't got long. And I've got my tripod sitting nice and squat, right down as close as it'll go. I have my theodolite set up here, and I'm measuring the angle to the surface of the water.
Check this out. You like this?
So let's see if this will line up. Oh, it's difficult. Okay, there. So I can put my crosshairs right at the top of the water. And look at that. It's 3 to 4 arc minutes above eye level. So the water level is appearing 3 to 4 arc minutes above eye level.
There you go. That's above eye level. It's a guy that's saying the water in the distance is above eye level.
It's like almost 1/10 of a degree. So that's very interesting. Now, if we were to point this straight and level,
That's his mic, not mine.
okay, I'm going down, down, oops, that's a little too far. Okay, that's about straight and level, which is below the surface of the water. See, there's straight and level, roughly within a half a arc minute.
There you go. Is everybody getting that? Everyone see that? The crosshairs, he's got it here, and the water is above. Now, I don't know if anybody's heard any ever claims about the horizon rising to eye level, which I state is impossible because the water can't rise. That's ridiculous to think the water can rise in the distance. But this guy might be a concave earther because he has got water rising in the distance.
That's not the water. That's a mirage.
That's what he says. It's the water.
Yeah, but it's not. It just appears to be the water. It's a mirage, just like George.
Well, I don't know. I mean, he might not have set his tills up in the comments.
Mm-mm.
There's
If you go back to the picture, the water is where that shiny bit meets the blue. That's the true water level.
Larry Scott says, did you flip 180 degrees and repeat? Did you perform the 0 calibration? Do that again and observe direct and reverse. And he says, I have not done zero calibration on this one. I have a pair of Pentaxes. But I did do one direct and one reverse yesterday. I keep telling myself I should do a zero calibrations, but I haven't done it yet. So he's not actually checked this at all.
He needs to check it and make sure his tool is calibrated, but the view into the distance has nothing to do with where that crosshair is my point. You can be easily fooled. It just blends in. It mirrors down and mirrors up, and it does all kind of crazy things.
Yeah, it could, all sorts of weird things can happen, right? But the one thing that is impossible to happen is that the water in the distance rises up above wherever you are. I mean, that's the worst thing that you could ever imagine to say.
Yeah.
Yet somebody seems to be saying it.
They all say it.
Yeah. So somebody says, I've always wondered how you can accurately vertically level a theodolite that doesn't have a compensator. Do you just get it as close as you can with the built-in spirit level and then average the flipped readings? This is people trying to work out how to adjust and calibrate a theodolite. They think that you can just do it by flipping it and adjusting the angle. He says, but in answer to your question, you just use the spirit level, but the spirit level is mounted on the rotating part. Even if the spirit level is out of adjustment a little, you can still level it because when you rotate the turret, the bubble doesn't move. In other words, it makes a differential reading because you adjust it and then you rotate it 180 degrees, and any error in the bubble level will become evident. He's literally just leveling his theodolite to the bubble. That's it. Now, I know an auto level has a compensator inside it that works and it hangs free once you get into that range. Theodolites aren't the same. They don't do the same thing. It says this technique allows you to very readily level the instrument to within the resolution of the instrument. It's good to check level periodically because the tripod legs can sink in the soil enough to shift the bubble without you realizing it, especially in frozen ground. It's you don't just get the bubble on the side of the level sorted. That's not a one-off thing. It says the bubble level is actually a calibrated instrument in and of itself. It stamps something like 30 seconds to 2 mils. The graduation marks are spaced at 2 mils. And the way it's marked, you center the bubble, and the human eye is exceedingly keen at detecting whether something is centered. So yes, you can get within an example 3 arc seconds easily. That would be a 10% off center, which your eye is almost certain to detect. 3 arc seconds is an inch at a mile, or the length of a housefly at 1,000 feet. So pretty meaningful. That's nice. I mean, all you're going to need to do is the bubble level at the side. Anyway. It's going above
bring this back up to the top of the water. Then it's about 3 arc minutes above eye level. So this sort of suggests that the high density gradient by the water's surface is actually causing things in the distance to appear higher than they are. Isn't that interesting?
He thinks the horizon's appearing higher than it is. And he says that, again, the theodolite is a device for measuring eye level. I think that's what he's trying to suggest. I think he moves it now, look.
Now I'm setting it up on its full height here. But I can't leave the camera paused too long or it'll quit. And then I won't have a continuous video. Alright, now I've got the theodolite put up at full height and about 5 feet above the water, roughly, and leveled out.
Notice he doesn't show us level at all.
We can get it to focus. There we go. Put it right to the top edge of the water, I guess. Well, top edge of the water is right about there. Apparently. Apparent top edge, anyway.
Like parallel.
It's Stacy holding this in front of here. And that is 2 degrees above eye level. So it looks like we're still getting quite a bit of refraction that's raising the horizon up, even from an observer height of about 5 feet.
So he's saying it again. It's raising the horizon up above eye level. That's it. I don't know, about 5-6 foot? 5 foot above the surface there. Still saying it's above in the distance. Impossible. But he's still saying it is. It's above that.
So I wonder if I could make it back to the shore and get up even higher without the camera stopping. I'll give it a try. Down there is where I was, and you can see I'm on an island and I'm getting flooded in. Packed some of my gear up and now I'm going back for the rest. Now I'm up near the parking lot where I am a good 5 feet higher at least than I was. Now I gotta level it out. Okay, I got it leveled out, and now the angle to the horizon, or to the water surface, the apparent water surface. Oops. It's very dicey holding it lined up there.
There is some mountains in the background.
Is that better? Yeah. See, there seems to be the water. Those are hills in the background.
Okay, hills.
That is focus. Focus. There we go. Only about 1.5 arc minutes above eye level. So
Again, above eye level. He's got a theodolite as being a tool for establishing eye level. And then determine that the horizon is above eye level. It's a big claim, Globe Surveyors. It's a good job you've got these guys out there. I mean, if we had Jesse and, you know, like the other guys that claim to be the proper surveyors, you wouldn't need these amateurs saying stupid stuff. But that's what they say. I mean, like, maybe this guy's a concave earther or something. I don't know. He might be a flat earther. Doesn't seem like a globe surveyor to me or anything.
Well, we're getting quite a lot of refraction.
This
today,
globe.
actually. And you can tell by how fuzzy the horizon looks, because we are literally seeing farther than we would with a straight light path.
Did you hear that? We're seeing farther than we should with a straight light path. Looking through his theodolite.
Straight light path or straight line path?
I'll see what he says.
We are literally seeing farther than we would with a straight light path.
He said light.
Yeah. Yeah.
A straight light path. Saying that, suggesting that it's not a straight light path that we've got there.
And the important thing to note is we're seeing it above us. Even standing right here with this precision angle measurement machine made in Japan.
Made in Japan. Made in Japan. Oh, well, it's a made in Japan one.
The water level horizon, the water horizon height actually appears slightly above eye level. Now I am going to try to go up on that hill. Focus. What's with my camera? Except over that way where there's a pull-out, and get a video from even higher and see what we get.
So for the 3 that he did, supposedly, the horizon in the distance is higher than where he is now. How would that happen? Possibly. I mean, what? What does this guy think he's doing? It's got it rising, the water rising in the distance above the level of this thing. I don't get it.
But I'll have to stop the camera for that. I might splice it together. It might be a separate video. Even that ship looks like a lot of the deck is missing. Interesting. Now I'm about 50 feet up or so. Is that the same ship we saw earlier, with most of its hull missing? Okay, this is with the theodolite set straight and level.
That's way above.
Okay, now we're pointing it at the water surface, which basically looks like right about there.
Looks like he's struggling to find it there.
There. But anyway, this one here is 5 arc minutes, 24 arc seconds down below eye level, and this one here is 4 arc minutes and 18 arc seconds below eye level. So now that we're 50 some odd feet up, now the water horizon is below eye level. So I guess that means we're up far enough above the water that most of the line of sight is far enough from the water that it's not in that increased density gradient that's right near the surface.
All right, there you go. So, we've now got a new contender with the water horizon above eye level. Take note, guys. The rising water level in the distance. Opposite to what Rumpus wants. Rumpus is after the drop. So, guys should be having a go at this. The rise and the drop. What do you reckon? We've been watching.
Who was the other guy? Was it George?
George did the rising. Yeah, that was Rakir got those pictures again. Early on. Early 2 years ago. Maybe even more now. Maybe getting close to 3 years ago that George gave Rakir those pictures of the rising horizon. I've never seen that before. George was the first to show us the horizon rising above eye level, supposed by the setting of the tool. And this is the second one. This is the next guy. From Jesse, sanctioned by Jesse Kozlowski.
Sanctioned.
Yeah. Well, he was. He was pushed forward by Jesse Kozlowski. I can remember his first show where he went over to Jose's. It was just sort of. We need to get to show that the. I don't know. I mean, let's have a conversation about it. Why would the water? I mean, we don't need to right now. Saying the Globers should, Rumpus should at least address this sort of a thing, seeing as there's no surveyors around or anything to talk about it. Rumpus is doing a test looking for the full nutsack drop. But this guy here seems to show that it rising. Or whether what model dictates what. But one's a drop and the other one's a rise. Jesse Kozlowski mentioned about a dropping level from the horizon, from the horizontal. And this guy from Jesse has said he's measured water horizon above eye level. So, we're going over all of the surveyors this week. That was just a little brief outline of what the model Affliction does to people. How the model Affliction acts on... I'm saying... I don't think any of these guys are actual surveyors. They're just all interpreting what the model dictates and what they need to say to feel happy within the model. Well, From Jesse has just shown us that he needs the water level to rise above eye level. I'm not so sure what his model is. I don't think he's shown us. I'm struggling to see how that would support a globe model in any way at all. But that's From Jesse to explain that one. He did have one about a water level as well, but we can go over that. I don't think he's a surveyor. It's just, I just wanted to point out that he's adding his. I mean, I suppose he's got better credentials than B-ball, and I've never seen blue marble science with the theodolite trying to practice anything like that or show anything. So, props to From Jesse for doing this stuff. So thanks for it. From Jesse, yeah, he's after a bit of stardom. He hasn't got that many subs either, so if you're a concave earther, I don't know, support From Jesse. I don't know. I don't know what the idea of it was. I just wanted to point it out because I thought it was opposite to what Rumpus was after. So it's worth pointing out. Rumpus has got some challenger. And the fact that Larry Scott commented on it. I pointed it out to him. So, thanks very much for watching. It's getting late again. I'm going to have to call it a day. Thanks for watching. Tomorrow we are going over logic. And thanks to Buster, I think tomorrow will be a pretty good one. Hopefully. Fingers crossed. See whether we can put it together. Go over a few of the methods and the particular techniques that we use over here, and hopefully other people can start employing them. So, Buster. Hopefully I might get a new Buster, long Buster sections for us. Anybody got any requests for Buster?
Dead straight lines.
Dead straight lines. Let's have it. There you go. Thank you very much, Cleary. See you tomorrow. Logic night. Going over a few methods about how to talk to people. Will be good. And will be stuff that you can definitely use. So join us tomorrow. Buster's singing us out.
Looking out upon the shore, I found balance and so much more. It's getting clearer all the time. All we see are all these dead straight lines, and show me what's in reality. And I won't compromise between the truth and lies. This is where I make my stand. take me to your la la land. It's all about geometry. All we see is horizontally. Show me what's in reality, and I won't compromise between the truth and lies. Show me what's in reality, and I won't compromise between the truth and lies. Reality is all I see. I don't need your fantasy. I've had enough of sophistry. I'll find my own philosophy. Reality is all I see. I don't need your fantasy. I've had enough of sophistry. I'll find my own philosophy, and you can't bend reality into what you think your cog sees. Something's happening to me. Don't remind me of how things used to be. We don't need no